with subdomains, what host names the company had. And then the CAB, the browser forum, said, you know what, if you guys are going to issue TLS certs, we don't trust you guys anymore. You need to issue all your certificates to a public transparency log that's a big signed Merkle tree. And in doing so, we've now got like real-time notification of domains being registered. So if you're setting up a new WordPress site, for example, and you use GoDaddy.com, well, the second you register that domain before WordPress is even like completely set up, you're not telling the entire world that that domain is live with a new TLS cert. And you don't want to connect to WordPress before there's TLS, because then you're sending your password across the network clear text. But as soon as you do it over TLS, you're now fighting to erase that before everyone else finds your WordPress site before you do. So if you run a CT tail, basically, like watch the flow of new domains being registered to CT, you can race people and steal their WordPress accounts before they finish setting them up. And just how it works. There's no fix for that right now. But one of the things a lot of folks don't realize is crt.sh is an amazing tool if you've ever been to the website. What a lot of people don't realize is there is no application there. There is no web stack. There's nothing but Postgres. The entire web interface of it is just Postgres. They built an entire web stack, like everything from search queries to HTML to templating to links is just SQL queries and SQL functions in the backend. It is insane, and you can find the source code. So don't let anyone tell you that just because you're DBA, you're not a full stack developer. One of the things you also don't realize about CRT shell or may not realize is they actually have a full-on SQL interface. You can just run psql -u guest -h crt.shell and run queries all day long. Like you don't even have to use their website at all. You can hit their database directly on the internet. Like they allow that. They're very brave. But the hard part is getting the SQL. Like how do you figure out this crazy SQL on the right side? Well, you have to go look at your web interface, pass the show SQL equal true, and then it'll give you the query you need to find the stuff. Then you adapt that query for your stuff going forward. So if you want to build automation to your tools using just pSQL, great, it's easy. Now, if you want to go the other direction, let's say you want to do this, but you don't want to tell crt.shell who you're trying to resolve all the time, or you want to go get the data directly yourself. Ends up it's really easy just to go take a list of all the active certificate transparency logs and then monitor the heads of those logs and tell you about new registrations in real time without having to tell anyone else about it. Effectively, you just write a tool that goes and looks at the 20-out logs. It says, what's the current index? Give me the last registrations. Show me the names. Spit them out. And so there's a little utility I wrote called ctail. It's at github.com, HTML ctail. And basically, it'll just spew out all the names as they're being registered in real time with whatever regex you want, and then you feed that into whatever attack tools you want. So if you want to look at identifying all the registrations for a given target domain name, for anything with a certain prefix like autodiscover or blog or whatever, it's really easy to do. And the project discovery team recently added similar support to the TLX utility for a sub-utility called ctutil. So I'm not sure if it's been officially released yet, but it's in the source tree. And that'll do something very similar as well. So if you want to drink directly from the CT fire hose, it's not that hard. So another fun thing is split DNS. Like a lot of folks don't realize that often external DNS servers will allow you to query internal DNS results. Like it's something that's been around forever, but folks don't actively look for it, and they should. The short version is first you look for, I'm going to have to fly. The first thing you need to look for is any outbound DNS server. So look for any DNS exposed to the internet. Great, scan that. And then brute force that for private IP ranges until you find results for it. You can do the same thing by looking for internal names like OpenSense, PFSense router. Setupmeraki.com is a special name where if you resolve it internally, it resolves to RFC 1918 IP, like a private IP. If you resolve it externally, it resolves to an AWS IP. So great way to know if you're inside or out. Another fun trick is you can actually use a open DNS resolver, so any DNS server that resolves your domains as a ping scanner. You can tell it to ping things it can reach, no one else can reach. You do that by creating a fake subdomain where the NS records for your fake sub-results point to internal servers and internal private IPs. And you tell it to basically do DNS lookups against internal systems, and based on the latency of that, you can determine whether that system resolves or not. So for example, we can scan the private range of Quad 9's internal network by looking at the latency results of doing IPv4 lookups with this crazy DNSRP tool, which you can also find in the references. So going to the next step, like how do we find things in the internal environment? Well, we find developers, repos, resources, find targets, find pivot points, and then go quick. So first thing I like to do is hunt for the developers themselves. Like find the folks who work at these companies, go through all their stuff, and try to find references to tooling, to packages, to resources, to domains you may not know about otherwise. Even better, if you can find the list of all the different developers, like in this case, this is the Microsoft repo, go steal all their SSH keys. They're all public. Just go up there and grab all their SSH keys. Now whenever you find an external machine with SSH enabled, you can just throw those keys against it and see whether or not they're allowed to log into it. So you can quickly, just using someone's public SSH key, you can see whether the server accepts it for that username and that key, even without having the private key part of it. So in doing so, you can figure out, does user A have access to this system? It's also useful for knowing, like, did we lock this user out or not? Well, if you have their pub key and just their pub key, you can still figure out whether they've got access to an internal machine or not. For a lot of Git repos, you don't actually need the username, you just need the pub key. It'll then tell you which username you're logging into just by doing half authentication. So there's some neat things to do with that. A couple ways you can do it. You can either take one key and throw it at all the servers on the internet, which is what we did when we were searching for like Giatan from his GitHub key. Or you can go the other way and you can take 1,000 keys and throw them against one server if you're trying to figure out which users have access to one server. So both methods you can do through the Shamble tool that released a couple years ago. Now, VPN appliances have become like the #1 way into networks. The Manhunt report from last year says like of their top 4 breaches, or sorry, the top 4 initial access vectors for all the breaches they investigated, they're all security appliances: Palo Alto, Avanti, and Fortinet. And if you've been in security for the last couple of years, it doesn't surprise you, but it's amazing that those are actually the biggest sources of breaches are security vendors. So another fun thing is remote desktop. Now, remote desktop used to be fun because you can get a copy of the desktop without logging into it. You can see the group names. You can mess with it, screenshot it, things like that. Then they added something called NLA. NLA is network level authentication. It makes you do a full end-to-end SSP handshake. That's actually even better half the time because it'll actually give you the domain name. It'll give you the OS version, all kinds of stuff during the handshake itself. So while remote desktop is something typically you don't see on the edge anymore because it's not something you want to expose, it's also something that you can still find through these other mechanisms. You can find it hanging out on IPv6 addresses that the user just doesn't know are there. And you can also find it through remote desktop gateways, through RD Web and other web interfaces to our remote desktop. Let's see, another fun ones are unintended V6 exposures overall. So there's a large university customer of ours who says, hey, our Hurricane Electric ISP accidentally routed all of our internal IPs to the internet through V6 to the 64 gateway. So if you have a Anycast 64 router, it'll actually just start routing all your external traffic, sorry, internal devices externally through a mapping layer that's predictable. And they found out the hard way when Shadow Server told them their RDP was exposed to the internet. Another example of this that comes up is cellular broadband IPs. If you've got a laptop and it's got like a mobile LTE adapter, typically you have a V6 address from your cellular provider, and depending on which network you're roaming on, you either have a firewall or no firewall, but you don't actually know. Like, a lot of folks just assume the cellular side is going to firewall you off, but a lot of cellular networks will actually just stick you directly on the internet too. So as you're roaming around, you go from like a public bare V6 address to not having a public bare V6. So as we're going kind of inside the network a little bit here, and I know we're short on time, so the question is, where do you go next? So you've got some foothold. What's the first thing you go after? Well, you don't go after the data first. You go after all the platforms that control access to the data. You go after the network management tools. You go after the admin's workstation. You go after the developer machines. Like, those machines will get you into everything else. They're not the things that you typically think of as being your first line of defense for your credit card data, but they're actually the most easy way to get to the credit card data is by going through those machines. So network management platforms are my favorite. I love popping SolarWinds, ManageEngine, PRTG, OpenMS because they've got all the clear text passwords to all the network devices. And it doesn't matter how good your segmentation is when the attacker has a password to your ASA and can just reconfigure your firewall. So I've been in a test before where we literally just opened a hole in the ASA firewall into the card data hole environment and just walked right into it because we had access to SolarWinds, which had access to push rules to the firewalls. So your segmentation doesn't matter if your attackers take over your device configuration. And it's just a really easy thing. So what I like about this is you can actually run the Flamingo tool at the command line for port 22, 161, et cetera, and immediately capture all the credentials from your local network management tools, and then turn around and replay those against the network and own all your stuff. So it's easy. Some other easy pivot points here are like NextNet, a little utility for doing NetBIOS reflection that gets you the secondary IPs. RPC dump will actually dump the endpoint mapper. Impact has a tool called Oxy2 Resolve, which gives you the multiple IPs for a single machine as well. A little more difficult is you can start looking for a device that support SNMP and looking for devices that have the same unique ID in multiple places, therefore you know it's the same machine. Or you can find systems that enable packet forwarding by default. So the surprising thing here is just about every printer and just about every desktop or laptop running Docker is actually also turning on IP forwarding by default. So if you take your laptop and you're plugged into the Ethernet and you're plugged into the Wi-Fi at your company and you're running Docker desktop, congratulations, you're now allowing everyone on the wireless network to route through your laptop to the corporate network. And no one knows because they didn't realize you turned on IP forwarding and there's no ACLs disabling that on your machine. So IP forwarding is everywhere and no one bothers checking for it and it's a lot of fun. So the DevTool hubs are also a lot of fun. You can go after the CIs, code forgers, artifact tools, et cetera. They tend to be chock full of credentials as people build packages that are not meant for external use. Config key value database is my favorite as well, going after Mongo, Redis, Console, et cetera. You basically can find all these services that are exposed to network no authentication that are chock full of credentials and fun things, including session IDs, which you then take to bypass logins. Mongo, I just want to complain about it temporarily here. So Mongo in version 5.0 said, you can no longer run our software on CPUs older than X. And so what did the world do? They said, well, that's great. We're just going to run ancient Mongo on our production systems from now on. So if you install Ubiquiti Unify in any system out there, it's going to be running an end-of-life version of MongoDB 4.4 because they literally cannot run newer binaries from Mongo on older ARM platforms. Even Cisco ICE, like the big enterprise tool, it actually includes 7 different versions of Mongo, and depending on how old your CPU is, it'll downgrade you to an end-of-life version if you run it on older than Halem or pre-Sandy Bridge Intel architecture. So it's pretty amazing that you have these like end-of-life tooling being packaged with fully patched software just because of that. Other fun things are login scripts, usually full of hard-coded passwords. Big fix relays are great to dig through and dump out packages. I love finding really old computers because if they've been around for a long time, it means they've been there for a reason. Someone couldn't get rid of them if they wanted to. So whatever the reason is, figure that out because that's why it's important. And also because it's ancient, it probably has all kinds of fun bugs. You can dust off some book from the library and still find ways to break into it. So printers are also a lot of fun. Not only are they pivot points, but they're chock full of credentials as well. And now the fun part is how do you get the loot? Well, focus on all the things that are old and odd and underprotected. Focus on out-of-band management, underlying storage systems, and the backup platforms. So find the weird stuff first. So what are there only a few of the network? How many AS400s do they have? Well, probably like one. How many HP3000s? How much of these old OT HMIs? Look for the things that don't look like their friends and go after them because they're probably missing ACLs, missing security updates compared to the rest. I love BMCs, KVM, serial servers for the same reason. They effectively provide a lower security way to bypass security of a much higher security system, and they typically leave authenticated sessions open. So if you pop a serial server, which tends to be like a janky IoT device, you now have 16 different logged-in shells of all your routers and all your firewalls. And these are only the routers and firewalls that matter because otherwise you wouldn't put a serial server on it. Like, it has to be important enough that you have out-of-bound access to it. So by definition, if it has a serial server attached, it's wide open and it's exposed, which is great. So those are good targets. IPMI is still a backdoor. Even with the latest version of Supermicro, they ship with IPMI by default. And because the state of California found that default passwords give you cancer, they now have to randomize the password instead. But the randomized password can still be cracked by RACP protocol, which is the IPMI handshake. And you can tell RACP, I would like that password in MD5 format, please. Or maybe SHA-1, or maybe SHA-256. But because you're able to pick which password hash you want from the protocol, you know it's storing a clear text on the server side. Because it has to, otherwise it can't calculate the hashes. So effectively, you can ask IPMI services to give you a hash in any format you want, and then go crack them really easily. Just turn off Llama for a little bit and get your shells. Another really fun one is NFS pings. A lot of folks will filter port 111, but they won't filter 2049 to the Mount D port. So like my earliest claim to fame was owning all of Yahoo's mail servers through NFS because they filtered the ARPC bind port, but they didn't filter NFS and Mount D. So you just mounted all the NFS shares to the internet and went through all their email. That was great. iSCSI, same thing. It supports authentication, but practically no one turns it on. And backup systems are one of my favorites. So a great example is Rapid7 said that more than 20% of all their incidents in 2024 involve ransomware attackers going into their Veeam backup replication systems. So that's it. Talk about getting it out, but effectively you know how to do this stuff already. Basically, AWS Sync, Loot, use SQL itself, use VPN tooling, use things like that, and that's it. So that's about 30-ish tips, 20 minutes. Thank you so much. No amount of time. If you have any questions, I'll be hanging out by the Run Zero booth in the back there. Thank you. Sorry. This is really wonderful section. I'm interested. So you covered all the tools. Awesome. I was trying to go really fast, but still not be too lost in the mud. Okay. Thanks so much.
Hey everybody, good afternoon guys. Welcome to B-Sides Las Vegas ground floor. You guys made it. So we're gonna have the talk titled Avoiding Credential Chaos, Authenticating Without Secrets. We have two speakers, Chitra Dharmarajan, and we also have Steve Jarvis right there. So before we go ahead, we'd like to thank our sponsors, especially our diamond sponsors, Adobe and Aikido, and our gold sponsors, Formal and DropZone AI. It's their support, along with our other sponsors, donors, and volunteers that make this event possible. And a few of the other announcements are, these talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, use the audience microphone so YouTube can also hear you. Make sure to point at the mic in the audience so people know where it is, and that'll be the speaker ops. As a reminder, the BsidesLV photo policy prohibits taking pictures without the explicit permission of everyone in frame. These talks are all being recorded and will be available on YouTube in the future. And with that, let's get started. So please welcome your speakers.
Hello, everyone. Good to see a room full of audience, completely filled with lunch here. So let's have some thoughts to share. Avoiding credential chaos, authenticating without secrets. That's a topic me and my colleague Steve Jarvis is here to discuss. A quick introduction. I'm Chitra Dharmarajan, VP of Security and Privacy Engineering at Okta. I love building high-performance teams across the globe, leading security transformations. Outside of my day job, I also advise many startups in Bay Area. And I love to grow along with technology and innovation these startups bring to the floor. And my security mantra is all about being an enabler, never be a gatekeeper in the career of security. And I have dropped my LinkedIn here, and I'm calling my colleague Steve Jarvis to give you a stellar introduction.
Yeah, hi everyone, my name's Steve Jarvis. I'm a security architect at Auth0 at Okta. And before I was in this position, I spent a long time software engineering on network and security, building software in that space. And that still frames a lot of how I think about security now. Outside of work, I spent a lot of time cycling. I'm a dad to a 4-year-old, and my favorite thing is cycling with that 4-year-old, actually. So my security mantra is the secure way has to be the simple way. Otherwise, there will become another way if it's not the easiest way. And that's a link to my personal site at the bottom. Once we're done here, I'll put the resources up there, too. So.
Thank you, Steve. And a little known fact about Steve. He has strong opinions about identity and even stronger opinions about bicycle tires. So if there are any bicyclists here, racers here, you have a subject matter expert to exchange thoughts. Okay. I want to say, your secrets are safe with us. This is a very safe space. Let's come clean. Let's share your secrets. Me and Steve has taken a pact to keep it safe with us. So in today's agenda, we are going to enable you to break up your relationship with shared credentials and secrets. We'll start with something like, you may be wondering, what's wrong if I have a few secrets? We keep them safe. No offense. It's just a little old-fashioned, and that's about it. And a lot of operational toil, secrets rotations. Then you may come to realize there are too many secrets that you have. Even your secrets may be having little secrets to keep. So how do you actually get rid of them? It's too much out of hands. That will be our second phase of discussion. And then we all will make together an executive decision to get rid of them. Time to break up. And we make that decision together. And then we as security practitioners, we only believe what we see, right? proof is always in the pudding. So there are going to be some cool demos about cross-cloud authentication without secrets. And finally, we leave this room in peace, knowing that our secrets are safe. Oh, wait. There will not be any secrets to safeguard. So we will be more at peace knowing that our secrets are cleaned out. So that's the goal and agenda for today's discussion. So enough having all that fun. No tech talk can start without some scary data points and numbers, right? So a global average cost of any data breach as of 2024, citing from Thomson Reuters, it's about 4.88 million is the cost for every single breach, and this is a global average. And I'm sure it's more than that, but this is what the industry has called it as a code. But just within US, the cost of an average breach, of a single average, cost of an average breach is about 10 million. And the cost increase is due to a lot of expenses with detection tools, credit monitoring services, regulations, fines, and everything. These are some tangible costs, but there is also a lot of intangible costs. This is more about loss of customer trust, employee anxiety, productivity, down leveling of the productivity, a lot of security operations work, and last but not the least, cost increase with cyber insurances. Most of the data breaches, they start with lost or stolen credentials. So let's understand the attacker's tactics so that we can strengthen our defenses. Most of the data breaches start with, either it's a compromised credentials, lost or stolen credentials, or harvested list of credentials from prior attacks with the aid of bots. Victim service or victim themselves are targeted for attackers' successful access and thereby the data breach. So before we go into the detailed discussion of this session, we all want to remember a golden rule. Thou shall not have the burden of any secrets. Let's call it out in our brain one more time. Thou shall not have the burden of any secrets. Like any golden rule, there is always going to be a caveat, right? So if you must have a secret, make it a point that you have it secured in HSMs or KMS and have some automated rotations put in place. Let's say you may still need to have some secrets in your environments for your bootstrapping of your infrastructure, whatsoever reason, whatever may be the reason, if you still want to keep some secrets, then we need to choose what we need to keep, and we need to bake automated rotations as a part of our security operations. Not when a bad day happens, it should be like everyday operations, like every 4 weeks, 6 weeks, when you do blue-green deployments, whatever you can rotate, you should be rotating to maintain the security posture. So rain or shine, we rotate them on time. If you plan to keep a secret, that's a liability we own. So with that preamble, let's think about a regular work day in a technology company where we have employees logging into their SaaS applications like Confluence, Slack, GitHub, and the CI/CD pipeline, deploying the workloads in your cloud infrastructure, SRE engineers accessing EC2 instances via SSH keys, and of course services accessing many of the resources via API token. Seems like a typical IT work day, right? This infrastructure is fully infested with a lot of risky secrets. An employee using a password instead of corporate SSO, and SRE engineer using an SSH key. Maybe they store them in their laptops, you never know, or the AWS config files. And service-to-service communications between Kubernetes microservices via shared secrets. And those API tokens, there is credentials everywhere. Anything that get logged via logs, anything that get harvested out, your production infrastructure is at risk. So, Steve, what do we do about this? How do we go from here to a clean state or the target state of secure infrastructure?
Yeah, thank you, Chitra. You might have to mute because I think we're getting feedback. So.
Okay.
Yeah, thanks, Chitra. So what are we going to do about it? Well, the goal here is that we're going to move one piece at a time, basically. We're starting with this picture on the left, which is our current state, how we're operating right now in our imaginary company. And we're going to try to get to this picture on the right. And the general idea is that, red, bad, blue, good. So we're going to see how we can change these different components, the way they're authenticating with each other, how we're managing these secrets, and dramatically reduce the burden that we're feeling. And we're going to go about this in 4 areas in particular. The first, we're going to look at the engineer's access to SaaS and servers. And then we're going to look at how our CI/CD, which is also in GitHub, and in this picture, GitHub is going to serve as both our version control and our continuous deployment, how that's accessing the cloud infrastructure to deploy resources. And then third, we're going to look at the API access here from our services. Our services need to talk to that API we're operating. And lastly, the communication of those services between Kubernetes clusters. And at each step, we'll suggest a different design, something different we could do, how we can improve the situation. So first, we'll check out the user auth. And this initial one is probably going to be familiar to just about everybody. Right? Passwords are so yesterday. So what we can do instead of a password is we can use some public-private key technology like WebAuthn, add an IDP to consolidate identity management, and we don't have those static persistent credentials around anymore. So for example, in WebAuthn, right, your device creates and generates a private key. And that private key is used to sign proof that you are you. Requiring a biometric to use that key to sign that assertion or that challenge is like a built-in second factor. So we get MFA automatically in this flow. And one of the big pain points originally with this was that that private key is strictly bound to your device. So if you made an account on your phone, you couldn't log in on your laptop. And that was really not workable. So back to the secure way has to be the easy way. This never caught on because that's a huge pain. So passkeys address this and syncing it to different devices. So this burden is largely gone now. We can use passwordless authentication. It's got built-in MFA, and it's a huge improvement, right? Because now in the login flow, that key, it never leaves your device. You couldn't leak this. It can't get phished. It can't leave. So, and also, assume there is a data breach at the provider, right? Like Chitra mentioned, that's like a fuel for a lot of this security incident cycle. If there is a breach and that database gets lost, they have the public key. They can't impersonate you the public key. So even if there is worst case breach, it's still relatively all right. Okay? So this is a quick win for our golden rule of not carrying the burden of secrets. We just offloaded a bunch of passwords to be the device's responsibility now. So the second thing we're going to look at is still in that engineer access. And right now, if we have an incident and we need to access some servers, we're relying on SSH keys. So this really means that every engineer that could possibly respond to an incident, which is typically all of them, are going to have a key on their laptop that probably lives just about forever. Right? So we're going to build on that same authentication flow we already have to leverage that IDP, but now we're going to use it to assume roles in AWS, temporary credentials that live for a short time, and combine that with a native service in AWS called Session Manager. So now we don't have a need for a secure shell session here. Session Manager is going to use AWS's APIs locally to establish a shell that the engineer can use in that environment. And so not only here are we eliminating some of the risk that we were carrying from these static credentials, we actually get to harden the host at the same time, because now we don't need any ports open to the internet. Okay? And this is a very AWS-specific picture, but again, like the things we're painting here are just for example purposes. The other major cloud providers have the same concepts available, right? So quick recap, we're moving through this picture really well. We've already kind of made a happy story out of all of the engineer's access, right? There's no secrets that we have to worry about in that part of the picture anymore. So now we're going to move a little bit right over to the CI/CD. And again, that's in GitHub's workflows. And that's what we're using to actually deploy our services to these clouds. So what we've been doing so far in GitHub workflows is provisioning static secrets, right? For deploying the AWS services, we have IAM users, access keys. To get stuff into Azure, we have the client ID and secret for a service principal. And those workflows, pull those secrets out of GitHub Secrets, deploy the infrastructure, and that all works all right. But we would love to not need to provision these, right? So what else can we do? Well, in this case, GitHub can actually act as an OIDC issuer, right? It will sign tokens for your workflow as a feature of GitHub. And so now we can kind of use that as the identity provider to assume these IAM roles and Entra service principals. And we don't need to provision any secrets anymore in GitHub. All we need is configuration. It needs to know what IAM role ARN to look at, what service principal to look at. We need to establish the trust in these clouds to say, we have an IAM role here. And if I get a token, an ID token from GitHub, it's allowed to do whatever this IAM role is allowed to do. It just becomes configuration. There's no more secrets in the picture. And we can and should lock that down to the specific GitHub repository and branch, and you really easily have that level of specificity when you're defining those rules. So, more quick progress. We've got a great mechanism for our human users. No more secrets there. Our CI/CD has limited the secrets from those workflows. And now, I suppose we should check out what our actual services are doing, what we're building, how are they communicating with each other. So if we go all the way to the right side of the diagram here, we have this service running in Kubernetes and Azure connecting to an API with an API token. So an API token here, this is a pre-configured shared secret, probably has an indefinite lifespan. And there's a lot of risk here because if this is transmitted as it is across the way, right? It exists in the same state on the client as it does the server. If we ever have a software bug or a logging error on either end of this, we're going to put that API token in a log somewhere. Any software vulnerability, we could leak it. We would really love to change this. So what else could we do? Well, we can use some more private key technology, right? And we're going to do something called a private key jot. And what that looks like is we generate a public key pair. Our service will sign attestations with that private key and submit them to our IDP. That IDP knows about our public key, so it can verify that we are the client that holds this private key, right? I trust this. We're going to give you a token, and it will issue an access token. That access token is what we can pass then to our API. And this access token is short-lived. It can live for hours, minutes, like how long do you need it? And we could very easily run through this flow again to refresh it. So now if we have a problem, and this key, this access token that we're actually submitting to the API ends up in a log or ends up breached, there's a very good chance that it's expired by the time anyone's able to do something with it, right? And that's actually not all. There's another really cool little win we get from here besides just the secrets management benefit. Because this is fully like OAuth 2 and we're getting a jot issued from an IDP, now we can also leverage custom claims and scopes here at the IDP. And those end up embedded in an access token. So before we had like a really opaque generic API key that get passed back and forth. Now we have an ability to define authorization values, right? Scopes, claims in the token at that IDP. So we've gotten more power to our IT administrators to control exactly what this service is allowed to do at the API. Not just that it's allowed to access it. Now we get more knobs to turn here. What ends up in that access token? What do we want to enforce? So cool. With that change, we're 3/4 of the way through the specific topics that we wanted to fix, right? We have removed all the credentials that the engineers had access to directly to access the SaaS and the servers in the cloud. Our CI/CD is happily humming along with no provision secrets. And the services that we have running in Kubernetes and Azure, they no longer need a static API token to interact. The last thing that we want to look at is the communication between these two services. We have clusters running in each cloud, and we want them to be able to talk to each other. Right now, those two services are using pre-shared secrets to communicate. And this is working. Right? It just means nothing magic about this. We just developed whatever, a 30-character magic string, and we make sure everyone knows the same one, and then they can talk to each other because no one else would know the same thing if we didn't put it there on purpose, right? And that works, but it's really actually a pain on redeployments, on fallbacks, because this is a distributed system. So we're trying to update. If we have to do rotation, we have to update this pre-shared secret at a bunch of disparate clusters, right? It's a difficult thing to do, and it's causing us a lot of heartache. So we would love to change this to rely on some PKI and mutual TLS. And we can use the certificates that are issued to these workloads to establish that identity and that root of trust. So then the real anchor of trust and the long-lived key is no longer these pre-shared secrets. It's the root CA private key. And that we can store in something like an HSM. So it will just issue in real life. There would probably be more levels here. It's not going to be the root just issuing search to the cluster, but say we have an intermediate here. But the point is this one's locked away in an HSM or even something physical like a bank vault. We have intermediaries. And then these ones that are used as identity for the services in the cluster, we can rotate those on every deployment. Every time we ship out a new cluster, just change it every time. So like it doesn't become an event to rotate anymore. It just happens. It's a normal day. We're shipping an update. We're going to get new certificates issued.
So Steve, not every infrastructure is mature to do the MTLS authentication, right? This requires a lot of service mesh configurations. So what are the other mechanisms that we can secure the service-to-service communications?
Yeah, good question. And that's fair, because this establishing PKI, we have to do device attestations. There's probably, like you mentioned, service mesh to actually control the access policies. There's a lot of prerequisites for something like this. So instead, yeah, sometimes we don't really need a BMW. A Camry is perfect. So thank you. We can improve the situation a little bit using this pre-shared key that's already present. So instead of passing that pre-shared key directly, we can use it as part of a building our own JOT, basically, or JWT token. We can put the values that we need in our own JOT, and we can use something like Happy's Iron module with that pre-shared key to both provide integrity and secrecy to that. We'll authenticate and we'll encrypt that JOT. And on each side, we have that pre-shared key. We'll be able to seal it on the sender, unseal it on the receiver, and then we get a little bit for improvement. Like it's admittedly a modest improvement over compared to something like a full PKI and MTLS, but it's for quite low cost. Right? Not coming out. So yeah. Yeah, so it's a simple improvement. We do improve the picture here by using something like an iron token.
Yeah. So Steve, as a part of this conversation, we are supposed to walk the audience through a very cool demo, right? We are supposed to talk about cloud-to-cloud resource access via authentication with no secrets.
Yeah, first I want to touch on actually the difference between why is this still an improvement? Because we're still burdened by these secrets, right? So yeah, we'll get to that in a second. That's good. But first, when we started talking, we talked about how we're going to remove these secrets from our system. And now in a couple places, like here with this pre-shared key, we didn't actually remove it. And before, if you remember, we were talking about the access to the client API. We just exchanged an API token for a private key. We still have stuff we have to take care of. Are we really reducing the burden? And we actually are, because in situations like this, they never leave the host. A private key or this pre-shared key now, it never leaves the service that it's provisioned for. It doesn't go over the wire. It doesn't end up on a server. And the token that does get sent is short-lived. Right? So if there is an issue, it'll expire quickly. We can rotate without worrying about a broader, longer-lived impact. And private keys we can lock away relatively more securely, HSM, KMS, something like that. So even though we do still have secrets, we're making better choices about the types of secrets that we have. how we rotate them as a regular part of deployments, and how we store them and manage them. So even though some still exist in our system, they always will, we can make better choices about what they are and how we treat them, and still significantly reduce our risk. So in the end, we end up with a happy all blue picture, right? We have all the connections we did originally, all the services are doing the same functions they were, there's the same authentication going on, but in this state, all the secrets are managed by like the IDP, stored in HSM, there are credentials that are in the system but rotated as a regular course of, say, our deployments every week, and it's a much better spot to be in. It feels good. Right?
Yeah, we still need to. Yeah, we still need to walk our audience through that cool demo.
That's right, we do.
Yeah, so do you think all we talked about is securing access of users, CI/CD, service-to-service authentication, but many tech infrastructure is all about multi-cloud ecosystem, right? A service running in one cloud accessing a resource from another cloud and vice versa. So do you think we can federate identity in inter-cloud communications?
Yeah, good question. I do. So let's look at that. I think we can extend this a little bit, because this is a common use case, so I love this. This is, say we have services running in one, and how do we authenticate to APIs in the other? So this is a little bit different than the inter-service communication we just had. Now say that we have maybe like a management plane that's running in one cloud, and we need to reach out to the APIs of the other, right? How can we federate across clouds without secrets here? So that's what we have. And there's kind of two different mechanisms we're going to talk about doing this, because it's going to go in both directions. So on this side here, we have Azure running Kubernetes on AKS with a single container, and we want that to be able to assume an IAM role in AWS. And then, again, all the rights and privileges that that IAM role has. On the other side here, we're running, again, Kubernetes on EKS in AWS, and it starts out the same. Kubernetes is going to issue a service account token to this container, and that's just a feature of Kubernetes natively. So that part's the same on both sides. But on this AWS side, we have more components. And the reason for that is in both of these situations, when Kubernetes issues that service account token, the issuer, or that trusted identity, is going to be tied directly to the cluster ID. And that might be fine, but if we're talking about hundreds or thousands of clusters or redeploying them regularly, now we have a new problem of like, how do we, here, we need to know what ID we're trusting. And if that's changing every day, they might be able to manage that, or maybe not. So the point here with these extra components is we ultimately get an ID token issued from Cognito. So if we think about this in like layers of the infrastructure, we have say in Terraform, we have the infrastructure that defines things like the ID providers, the clusters themselves, the IAM roles. And then we have Kubernetes, the actual manifests, and that's where we're going to find what services are running, how those AKS and EKS clusters are configured. And then we have the actual applications. And some of the challenge here is that when we change that, like redeploy the Kubernetes cluster, it has ties to the infrastructure level configuration. So we would need to manage that a little bit differently. By introducing Cognito as an issuer there, what we get is a stable, trusted issuer in AWS that is separated from the EKS issuer. Does that make sense? So we've kind of broken the intrinsic tie between this and ultimately what Entra has to trust. Cognito will stick around across cluster redeployments. Right?
So in this case, Cognito is helping us persist the ID that's being federated across the cloud.
Exactly. Yes. Yes. So this is running now. And what we're going to do is we have 3 problems at key points. So this is all set up. This is running. And we have 3 issues. The first one is from Azure, just trying to assume that IAM role. We have a bug with that role assumption. The nice thing is the Azure to AWS story is pretty simple. There's only one hop, so that's where the problem is. We know it is. In On the AWS side, we have two more problems. One is we get the service account issued, but we're failing to assume that IAM role with URSA. URSA IAM roles for service accounts is an AWS service feature. And the third one is actually being able to get that ID token from Cognito. So give me one moment. I'm going to switch to mirror mode because I'm going to actually really do this live, but I can't see what I'm typing on this mode. Have a mouse. Where'd my stuff go? Okay. Okay, great. So this is running. On the top left, in this pane, we have the live output from the cluster or from the application running in AWS. And on the right, we have the output from the app running in Azure. All right, and we're going to start with the one on the right. So we see it has failed to assume the AWS role. There's no OpenID Connect provider found for this issuer. And like I said, this is kind of the issue of the cluster ID changing. This format looks like this is the subscription ID, and this is the cluster ID. So every time we redeploy the cluster, fail over, roll back, that's going to change. And now we're going to actually look at the source code for this. And this is split up in the same kind of hierarchy I described it earlier. We have Terraform defining the infrastructure. We have Kubernetes manifests defining what Kubernetes is running. And then we have a couple Python apps, one running in each one. And the goal of those applications is simply to assume the role and dump something about the identity in the environment just to show that we have the desired access. Right? So the first issue here is that this issuer was basically the last version of our Azure cluster. Right? We redeployed it. We forgot to change this. So I'm going to comment that out. And in this case, I have the correct value provided as a variable because, of course, this is all defined in one repository. I'm just deploying it here so I know what the correct value is already. So once we redeploy that, I'd expect the logs on the top right to automatically correct themselves. So what's going to happen is this. I have make targets, so I don't have to think too hard here live, but it's just going to run a Terraform apply right now. And that will fix the IAM role identity provider, or specifically the IAM identity provider that's allowed to assume this role to match the actual cluster ID that we have running over there.
So with every blue-green deployment, if we reconfigure the issuer ID in the other cloud, federation makes it easier.
Yeah. Yep. Yeah, and this is something that could be, like I'm automating it here. There's a solution here. I don't mean to overcomplicate AWS. There's probably a fix on this one too. There's just going to be trade-offs, whichever way you want to go. Okay, so that'll turn green if it doesn't make me a liar. Should have made it sleep less. Yay, green. So now we see we have the issuer that we changed it to. And then the proof in this pudding is that we assumed the role or role in AWS. That's just a call to STS who am I, right? Okay, so now we're going to keep going on. We're going to look at the second issue here over in AWS land now, because now Azure's working. We're going to shift our focus to AWS. And here we see that we are not authorized to perform that assume role with identity. So we have a Kubernetes service account. We want to change it into an IAM role, and we're not authorized to call that. This one's a little bit more opaque, but again, I get the advantage of having written these bugs on purpose, so I know to look in the service account annotation that we put on Kubernetes, because this is how you assume a role with IAM roles for service accounts with URSA. You add an annotation to the pod for a role that your Kubernetes pod is allowed to assume. And in this case, we have the wrong ARN. And we know that because wrong is in the name. So again, looking at the EKS config here, this is another relatively simple mistake to make, but we're going to change that annotation to be the correct ARN for the role that we're actually allowed to assume. We're going to deploy those apps, and so make deploy apps, that's going to apply that Kubernetes manifest that we just updated. And then a refresh is simply going to scale down the deployment and scale it back up, so I force it to take up the new config. Deploy a new pod, take up the new config. While that's thinking, I'm going to just start talking about the third. Okay? We'll come back to that in a second, because it should just take a minute. So the third problem here is once we fix this problem, we'll actually have an URSA role that's allowed to use Cognito. And then we want to make the call to Cognito and say, hey, I'd love to get an ID token from you with that nice stable issuer, and then use that to assume service principal and Entra. And for this final problem, we're going to move up to the application level. We have a couple Python apps here. And the problem here is going to be pretty simple. Basically, we have that service account token that's issued by Kubernetes. Kubernetes issues that prefixed with the protocol of the issuer, HTTPS. Cognito doesn't want the issuer. It just wants the domain and the rest of the URI. So we're just going to get rid of it. And that's that. Once we have that, Cognito should happily issue us an ID token, because we're saying then that we want to use that login, the issuer that you expect, that we've configured you to be allowed to issue an ID token to. And here's ours. But first, let's check to see if we got past that last problem. Yeah, so before, we still have a problem, but before we were not allowed to assume role with web identity. Now we have a role. Now we just have an invalid login token. And obviously, if I check the service account annotation again, we should see it updated to be the actual EKS workload role that's allowed to be here. So one more bug fix for this final step, and it should light up all green. Thinking for a second, I changed the application, so what I need to do is rebuild the containers and push those to the registries. So this is actually going to build into an image locally, push to ACR and ECR, and we should be set there. OK, since this is going for a second, why don't we move on to the learnings? Pushing was quicker before. A lot of people in here. So that's all right. I'll move on to some of our takeaways here, and we'll come back and check on the status of that in a second.
So the key takeaways which we want to reiterate for the audience here is, thou shall not have the burden of secrets, the golden rule, right? So it's incumbent upon us to design in a way to remove static credentials wherever possible. Let's say if there is an opportunity to leverage passwordless solutions for people login, be it SSM or passkeys, go for it. Utilize managed identities and trusted IDPs for service-to-service communications. Service API communications. And service-to-service communications, whether it could be an MTLS or some kind of IAM tokens where the shared secrets is not sent across the communicating entities. So coming to the second part, the caveat number 1, if you must have a secret somewhere, thou shalt secure the secrets, right? Think about HSM or KMS. Think about securing them with the hardware protection there. And if you must keep some secrets in some environment somewhere, for whatsoever reason, it's incumbent upon us to make sure that we frequently rotate them. So choose the right secrets to keep and bake them as a part of your regular rotations in your operations. So let's keep these golden rules in mind when we build our systems, when we build our infrastructures. Yeah. Thank you.
Awesome. Yeah, thank you all. And I'm definitely going to show this all green in a second, too. And I can't. I'm not going to leave it broken.
Live demo is always tricky one. Like, Steve, you did it awesome.
Yeah. Any questions or thoughts, or I'll just talk for another minute. Yeah.
Hi. Could you explain a bit more about those iron tokens and how they work? I'm guessing they're just like a certificate?
No, the iron token is going to do like a password-based key derivation to generate keys based. You give it just a string, a random string that you share on each side, and it will generate the keys necessary to do the crypto for the authentication and the secrecy, kind of on the fly.
Okay, thanks.
Yeah. Screen. Sorry, I just put that. So anyway. All right. Thanks, everybody.
Thank you.
Thank you, guys.
What's that?
Hello, everybody. Good afternoon, and welcome to B-Sides Las Vegas ground floor. So this talk is Hacking Secure Coding into Education by our speakers today, Or Sahar and Yariv Tal. So before we begin, a few quick announcements. We'd like to thank our sponsors, especially our diamond sponsors, Adobe and Aikido, and our gold sponsors, Profit and Run Zero. It's their support, along with our other sponsors, donors, and volunteers that make this event possible. Next, these talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to be silent.
Forgot the camera.
If you have a question, we will provide the audience microphone so that YouTube can also hear you. This is the audience microphone I'm holding in my hand right now. As a reminder, the BsidesLV photo policy prohibits taking any pictures without explicit permission. These talks are all being recorded and will be available on YouTube in the future. And I would request if you guys could move to the front, just so that we can have those who are coming to be seated in the back. With that, let's get started. Please welcome your speakers.
So, hi everyone, and welcome to Hacking Secure Coding into Education. We're very happy to be here. My name is Elsal. I was a developer for many years. 10 years ago, I switched my career path into cybersecurity. I also enjoy penetration testing right now, and also do some consulting and secure coding workshop in the governmental section and also in the private section. My drug of choice is Snowy Mountain, and this is VPNs Summit in Switzerland.
Hi everyone, my name is Yariv. I was a developer for many years, 40 years, and I also lectured in universities, mentored in boot camps, and about 5 years ago, I became an AppSec researcher. And my drug of choice is roller coasters, which is why I'm upside down.
Not only because of that.
So, education. Why do we care?
Why do we care? Why do we care? 2025, and code is still insecure. The same vulnerabilities appear again and again and again. Yariv, are we still talking about SQL injection?
Yes, so apparently we are, even though it was first discussed 27 years ago in 1998. Still in 2023, we had a major SQL injection-related breach, the MOVEit breach, whichever of you remembers.
With $9 billion lost.
Yes. So much so that 2024, Uncle Sam said they will no longer forgive SQL injection flaws. But I don't think it's much better with other vulnerabilities, is it?
No, the same goes for XSS, post-traversal, insecure file upload, and more, and more. And now we have the AI as well, and more. I said AI for the first time and the last time, maybe. So we had a huge ecosystem. We have so many tools. We have SAST and DAST and SCA, and we have threat modeling, and we have all these tools and methodologies. Usually happens after the code is already produced by developers. Except from threat modeling. maybe, sometimes. So, Yariv, tell us, or hurry, tell us, why do we keep failing?
Well, thank you. My son learned in high school internet programming, that's what they call it. And
vulnerability programming.
Internet programming, and they needed to do a user login, check the username and the password. Here's how they taught them to do it. Okay, it's a bit hard to see, But who sees the vulnerabilities?
How
Come on,
many
shout.
vulnerabilities?
Help us out.
At least two. At least two.
At least two. You're almost there. Who sees? Well, anyone. Okay, yeah, you can do SQL injection on both the name and the password because they're not validated or sanitized. What more? Well, here's a nice one. They use like. Anybody knows what like does? It's like it uses wildcards. So basically, if I pass for the password the % sign, that's a catch-all. So no need for SQL injection even. And the third one is, what did they forget to show that you have to do with passwords? Hashing. Yeah. Someone said it over there.
Hashing.
No password hashing. So 3 vulnerabilities in a single slide, and this is how we teach. So,
Not us.
next slide.
This is
True,
our
not us.
day.
This is how
They
they teach. Thank you. So if this is how our students are taught, how our programmers are taught, how can we expect code to be secure? I mean, it would be ludicrous, right?
So we decided, and Rachel here, remember, we shift all the way to the left, to the beginning of time before developers become developers. So,
Yeah. So 2022, we went to AppSec Global of OWASP, and we said, coding education must change. And we gave this lecture, and we were sure that universities will learn the errors of their ways and start teaching secure code. And high schools will teach their students to do parameterized queries and not concatenating strings. And nothing happened. So we did it ourselves. Remind me, how did we manage to reach high schools?
yeah, so a good friend of mine is a computer science teacher in high school. So we reached out to him and we asked him, give us your materials. He shared his materials with like 300 or 400 teachers all over the country. And we asked him to see the materials and we made some comments about the material. We asked him to change this and to change that, and we had a lot of discussions about that, and it took a lot of time and nothing has been done. So he said like, okay, come to my high school, give us a workshop. We are not gonna change the materials right now, it's a lot of work, but come to my school, teach my students. We went, high school students, we gave a workshop. It was very good, they like it. He spread the word for us, talk about the workshop with other students, with other teachers all over the country. We also went to a computer science gathering at the summer, and we spoke to them, and they helped us to spread the word about Secure from Scratch, and we started to go to travel all over the country to share our knowledge. Yeah.
But this wasn't enough. Somehow, we found ourselves teaching in universities. Well, again, back to you.
Yeah, so if you wonder if LinkedIn is a good tool, so we are the proof that it actually is. So one professor from one of the universities in our country addressed me and asked me if we can teach their students secure coding. And he knew to send me a message because of my LinkedIn post. So yeah, we said, of course I say yes. And then I called Yariv.
Yeah, we had nothing ready. Okay,
like,
not even a syllabus.
It's a full semester, like 13 lessons of 4 hours each.
4 hours
one.
each, yes.
Yeah, well, I think about it.
And
That's
this is
nothing.
like 4 weeks before the semester is about to begin. So we sent a syllabus.
It was very nervous.
Yeah, after every time I gave the lecture to the students there, I came home and I didn't even take the rest of the day off. I was like, let's start the next week. Otherwise, I'm gonna have nothing. So I wouldn't suggest, okay, this is how we did it. Don't go and do it yourselves this way. But we pretty much wrote the entire semester during the semester itself.
Yeah.
And then,
After a while,
number 4.
yeah, I'm looking for it because I forget how to say it in English. So after a while, someone told the National Cyber Directorate in our country, someone told us about us. So they called me and say, why, do you want us to give your name to all the universities around the country, some colleges? Yes, of course. Are you available for all of them? Yes, of course. We're going to go everywhere. So, yeah. And then we found ourselves, like, each one of us in a separate academic institution, sharing the same knowledge, the same course for everyone. Yeah.
Yeah, which kind of gave us the idea to scale up by using YouTube, and we filmed some reels to make it easier for us to go to that many universities.
Yeah.
Which brings us to the next item. Everyone else. So, yeah,
Now we come back. After San Francisco, we went to San Francisco. We went to spread the word we went to spread Secure from Scratch all over the world. Then we come back to the country, and now we come back to the States. We really want to help everyone.
Mm-hmm. And since we have YouTubes, so everyone can watch them, everyone can learn. It's a full, well, it's going to be a full course because we're redoing the YouTubes with better visuals. And of course, we want to spread it, so we also give workshops worldwide, including in DEF CON. And of course, we are talking.
Third time.
Second time, the workshop,
Third
right?
time.
Third time? Third
Yeah.
time. Wow. Wow. And we're also talking about it here in BSides Las Vegas. So that's another thing. Of course, you want to know, how do we build workshops that developers like? Because we all know those workshops that developers just see them and they're like, this is a punishment, I would rather go back to work, and we don't like that.
Yeah. So what do we do? The secret is that most of the developers, they don't like to know everything about security. For sure, they don't want to know all these special magic terminology that we use. XSS, CSRF, SSRF, RCE. I'm getting very excited when I hear RCE. Like, I'm very happy. I want to be able to get RCE in every penetration testing I do. But for developers, what are you talking about? Just leave us alone and let us build. We want to build. So when we create workshop, we focus on coding. We don't just, tell them this is a vulnerability, this is how we fix it. No, we give them some tasks, and we know to put the trap in the task. Like we tell them, develop this and that, and then we know that they will do it in the wrong way. Like 11 out of 12 developers fall in our traps. So we know that they're going to do it wrongly. And then after they try the task, the lab by their own, then we know, okay, now let's hack to your solution. And some developers, they don't like the hacking step, so it's fine. We leave them. Okay, you just need to develop. If you want to try the hacking phase, it's fine. Otherwise, we'll show you how we hack into your system. So not everyone, the one who does like it, enjoy. The other ones, okay, just go ahead. So we prepared a skeleton, and they build into the skeleton. We give some actionable advice. We also took all the information. We have a lot of information. There is OWASP Top 10 that is mainly for security professionals. It's more like what not to do than what to do. And there is also other projects that deal with security guidelines, but it's a lot of 5 minutes. Yeah, I cannot see well.
We're good.
Yeah. So, so we condense all this information to prevent, and we show you soon.
It's on the next slide.
Yeah, it's the next one.
So like, one
Yeah.
more?
More.
There
Yeah.
we go.
This is prevent.
Yeah.
Prevent.
It's an acronym, and it's a good acronym. How do I know? Because I use it myself when I write servers.
No, it's good because you created it.
I admit, we co-created it, but I actually use it myself, okay? It's not something that's academic or, it will probably work. It's inspired by Solid, if you know Solid from object-oriented programming. So the idea, again, was let's have an acronym that helps people program securely. And we're not going to go over it, don't worry. There's a YouTube on it, so you can just go and look at it. And even after that, it requires training to really get into it.
So we have a lot to offer. What do we have?
Well,
What do we have?
okay, so first of all, First of all, this is my minor project in OWASP and Trust. It's not something big. It's just a project that replaces right now just the path library in Python and in Java. And the idea is if you use this, it's kind of like the parameterized query version for paths. Once you use this, you can never have a path traversal. Never. It makes it impossible. Just like parameterized queries makes SQL injection impossible, the same goes, this does it for paths. So you can go and take a look and use it. That would make my day. But it's really just one small minor pet project of mine. The bigger ones are?
Yeah, so this is our repository, and it's an open source. And we put there everything, like every workshop that we give in high school or in the university, or even when the private sectors, when private customers, they ask us a workshop, we develop the workshop, they pay the money for the workshop, but then we share it with everyone. Like, and they, you know, they're totally fine with it. This is how they sponsor the materials that we share with the community, so it's fine. Yeah, so everything is there. Please feel free to use it, to give some, maybe. What is that?
Oh, that's me. No, go back. That's the
You wanna go
YouTube.
there? Oh,
Yeah.
okay.
Oh, but
And
it
the
doesn't
YouTube,
work.
yeah, of course.
It's supposed to
Yeah.
to run and show the YouTubes. Try moving one back and one forward.
Woo.
And one forward. Oh, there. Okay, so this is just a sample of our YouTubes and the evolution, okay? It was really bad in the beginning, just slides, but got better. This is our newer version. I'm showing you the iteration for two reasons. One, if you're doing a project, don't despair if it doesn't look nice the first or second time. You'll have to iterate. And two, the English versions are being transformed, and still a lot of them are being recorded. So don't be despaired that there's not a lot out there in English right now. It's going to be there. And we have Hebrew versions, which we will put translations, subtitles into English. Just give us a couple of days.
Actually, it's our philosophy. As much as we agreed to fail in the first time, the YouTube were bad. Also, you know, my very first YouTube about Secure from Scratch were really bad. And then we agreed to fail as much as we encourage our students to fail and then learn something out of it.
Mm-hmm.
So this is a call for action. Please spread the word about Secure from Scratch. Send us your feedback. We really need your feedback. If you want to provide walkthrough, it's also be very good. And
Arrange a workshop.
yeah, if you want to develop a workshop and share with us, we put it in the repository and we share it with the community.
Yeah, or take the workshop from our GitHub and do it in your workplace. Or, of course, you can do the course.
Yeah, the Java course. It's like a full semester course in Java, secure coding in Java.
And
Summary. 2025, and code is still insecure. The same vulnerabilities appear again and again. We want to shift all the way to the left, to the beginning of time before developers become developers. Even now, it's more important because we saw developers, what they do, they use AI. AI use between 40 to 50, AI create 40, and between 40 to 50% of the time vulnerable code. So we want our students to learn how to code securely, and or to ask the agents to provide secure code. And I say AI in the second time. So please help us. Help yourself. Help your friends.
and the
And what?
voila demo.
Ah,
Okay.
and demo. Ah, we have
So
time
we,
for demo.
we
Do
actually
have
have more time than we
time?
thought.
Really? Really? Oh.
So I'm just going to show you a small demo.
Yeah.
Usually there's some preamble to this explaining things, but this is like how we do it in high school, for example. There's no network, no web. We just say, imagine a computer that your teachers put in the hall room, and they put a questionnaire there. And you come to this computer, you put in your name, so I'll put in my name.
Yeah, it's super simple. You don't have to know any framework or web developing, like just a very simple console.
And you get the daily question, which today is, what is the capital of Assyria? Who knows where this is from? Really? No Monty Python? One Monty Python fan. Okay. So I'm going to give the wrong answer here. And okay, so imagine many students come and do this, and then the teachers, at the end of the day, they come and they say that they are the teacher, and they get a list of who was right and who was wrong. And let's do one that's right. Bolsa is going to be right, and again, the teacher. All right. And now the big question. The teachers said they're going to do this for 3 months with many, many questions. And of course, I can Google the answers, but I'm lazy. I want to...
There's no network.
I want
It's
the teachers...
full. No network.
I have my phone. I want the teachers to think I am right, even when I am wrong. So I want a method that I can pass these 3 months, so the teachers always think that I'm right. And the question is, what can you put here so you hack the system, and when the teachers look at your name, they see that you are right no matter what? What? Ah, nice one. Okay, let's try that. And, oh, illegal characters. But that's easy to, I'll just use, I think it's because
I think you run the...
Yeah,
the,
I'm one of the more advanced
one of the
version.
fixed version, but it's still vulnerable.
Yeah, it was supposed to be vulnerable. See, this is why demos never work. But let's assume that the column, this is actually a fixed version, well, one attempt to fix. And the problem with your suggestion, though, is that it doesn't work. See? Wrong, right, Yariv Tal. It doesn't work. It doesn't make me look right.
But
It's a good idea, though.
Yeah, the students also suggest this one, but also there is another disadvantage because some of the people, their second name is right.
Yeah.
So you cannot block their last name. You have some issues with...
So we're not going to solve this. You can go and do it.
Yeah.
In the YouTubes, there's a walkthrough. So we're not going to solve this. But you see, this is a very simple scenario because it's for high school.
Yeah.
And yet, there's an element here of, what can be done? There's an intentional element that's supposed to be at least an intentional element of mischief and rivalry, like how can we cheat the system? And after they do that and they understand hacking, we go with them to, okay, how do we protect it? And of course, they offer all kinds of blocking methods. We show them why that doesn't work. And
Yeah.
that's basically it, right? And
Yeah.
now questions.
Go back to the
Oh, go back to.
presentation. Yeah. Thank you so much.
We have time. 5 minutes for questions or no time? No time. All right.
Yeah. So thank
So
you
no
so much
questions.
for coming here today.
Yeah. If you have private questions, we're here. Well, outside, I guess, but but here. I don't know.
And DEF CON, we give
actually.
Hello, everybody. Good evening. Welcome, welcome. Welcome to B-Sides Las Vegas, ground floor. This talk is going to be about Lumina casting light on shadow cloud deployment, and is given by our speakers, Chapin and Brittany. A few quick announcements before we begin. We'd like to thank our sponsors, especially our diamond sponsors, Adobe and Aikido, and our gold sponsors, Formal and Profit. It's their support, along with our other sponsors, donors, and volunteers that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, please use the audience microphone so YouTube can hear you. So I'm holding the audience microphone. I'll bring it around if you have a question. As a reminder, the B-Sides Las Vegas photo policy prohibits taking pictures without explicit permission. These talks are all being recorded and will be available on YouTube in the future. So if you are coming in, if you just walked in, please move to the front so that we also have audience who are coming in can sit. With that, let's get started. Please welcome our speakers.
Awesome. To get started, any incident responders in the crowd here? Couple. All right, anyone dealt with a cyber issue that resulted from an exposed cloud resource before? Of course. All right, if you have or have not, welcome. Hopefully we can shed some light on shadow cloud deployments.
Yeah, thank you all for coming. This is actually really great timing. Like with the talk before was all about shifting as far left as possible and looking at secure coding as a part of education. We're going to be talking about as far right as possible, like when everything's already out, and trying to figure out like how to detect those resources and start that investigation. I'm Chapin Bryce. I'm a incident response consultant turned developer. These days I focus on cloud infrastructure and threat data.
And I'm Brittany Arjurakis. I've hopped around the consulting world a little bit, did a little bit of private consulting, government consulting, and now I'm on an incident response team at an enterprise. So one thing we've noticed through our combined years of experience is that as cloud has become more popular, the same security issues leading to vulnerable exposures has also moved to the cloud. So it's no longer your web application that's hosted in a data center per se, that's your initial access vector. It is now living somewhere in the cloud and is easier than ever to deploy. So as an incident responder, where do you actually start with dealing with some of these issues? There's a ton of tools out there. We did a lot of research when we initially had this idea. A lot of brilliant people have built some great solutions with respect to perimeter scanning and network mapping. Though what we were seeing didn't really fit the bill for an incident response perspective. There were some SaaS tools out there. There were some that were more catered towards pen testing and red teaming, but nothing that was really incident response focused. So we decided to build our own. So where are we actually seeing this? We wanted to kind of generalize and categorize different scenarios where we would probably be seeing these types of exposures. The first one being organizations that didn't necessarily have adequate logging or governance established, which isn't necessarily unique to cloud per se, but we did see that it was kind of a generalized trend. Cloud technically is kind of a new concept that's still being adopted by organizations and being rolled out. And as a result, policy is still being written and adopted as well. So it's easy to cut corners and not have adequate guidelines in place. You kind of adopt this just get it running mentality.
The other place we frequently see it is the shadow infrastructure, the shadow IT. Once again, like shadow IT has just shifted to the cloud. What was shadow IT that maybe was only internally accessible before is now having public IP addresses. The barrier to entry for getting a public IP and putting resources online is a credit card, free tier, right? Folks are able to spin up resources that maybe were problematic when they were internal, but now have a much higher exposure.
Yep. So why and how is this actually happening? Apologize for any of the introverts that are out there in the crowd right now. I'm going to ask for some audience participation, so buckle up. I'm going to go through some excuses that we have heard from resource owners in the past for why they have exposed those resources. If you've heard this one, please raise your hand. This is just a proof of concept.
So like, I'd say most of the room raised their hands. How many of those, same folks, how many of those turned production? Yeah, I've seen it too.
Yep.
I saw it in this past week.
Yep. Next one. Don't worry, it's just test data.
Yep, about the same number, a little bit less maybe, yeah.
Yep, exactly. Yeah, it's a clone of prod, but it's in our dev account, David.
Yeah, so like, what does that actually mean? Is it, like, what is test data? Is it your just production data in test? Or is it actually sanitized? Is it generated from scratch? Like, yeah.
Exactly.
A lot of questions.
Yeah.
Dev accounts aren't safe just because they're dev.
Yeah, exactly. And then finally, I didn't know it needed a security review.
Yeah.
A little bit less on this one, but this goes back to the just get it running mentality. I see this one frequently with that. So that's fun, but let's kind of dig into the scary part of this. Does anyone remember what happened with the AI company DeepSeek around January of this year? See a couple nodded.
Yep.
Yeah, all right. I thought so. Yeah, so if you're not familiar, the security research company Wiz published an article where they were able to identify a ClickHouse database that was publicly exposed on 2 different ports. They were just kind of enumerating the internet. We're able to see that there were non-standard HTTP, HTTPS ports out there. This ClickHouse client was fully unauthenticated. So as you can see from this screenshot, they were able to execute SQL queries directly from the browser. So you could see all the tables that they were able to dump and execute it directly from the browser. You know, this is worst case scenario. They were able to dump full chat history. You know, they also had full back-end issues and some sensitive data that they were also able to dump as well, such as log streams, API secrets, and other proprietary information. So this is obviously worst-case scenario, but it's a prime example of how exposed endpoints could be exploited as an initial attack vector.
Obligatory.
Yeah, and that was our obligatory AI mention. Here's what we normally see. You know, that's what hits headlines. This is what we see probably more common, cryptojacking. So it's not necessarily your full network takeover or PII database being dumped. It's probably just a really huge bill from CPU usage. One thing that I did want to mention before I move on is, you know, I think we kind of associate web applications and even cryptojacking with Linux systems. As we were looking at different case studies, we were able to see that it wasn't necessarily focused on Linux systems fully. You know, there was a CVE in 2017 affecting Oracle WebLogic servers that were running on Windows systems that threat actors were able to exploit and run Monero on. So I don't want to hear anyone say that they're safe in this room because they were running Windows on their systems. Just kidding, but not really.
Yeah, so there's a lot of great tools out there, as we were talking about before, and these are some of them. They really have a different focus than Luminat on that continuous monitoring. Some of them are SaaS focused, looking more at the pen testing side. Prowler's actually here this week at DEF CON, so check them out at DEF CON. But they didn't quite scratch the itch of, I'm rolling into an incident blind, I need to figure out what's exposed and start answering questions as soon as possible. And that's where Luminat is really aiming. So it's really for that quick triage piece. It's not meant for like a continuous scanning or, it's really meant to answer those initial questions and help you get started in your investigation. So it's aiming for these questions here that you're gonna have to start answering very, very quickly. It's also intended for environments where you don't really have the time to do a bunch of configuration. So the idea is the tool is as minimal configuration as possible. You can run Luminat without configuring it. We have some reasonable defaults in place. That way you can just hit the ground running in your investigation. You don't need to spend a lot of time setting it up and like safe listing or allow listing resources to get going. So this is Luminat. We kind of have a inside-outside approach. So we start inside the cloud, getting a list of all the public IP addresses. Then we gather context around what resources those IP addresses are associated with. So including firewall rules, compute, and so on. There's many more resources we don't yet support. We'd love to support them. But once we have a sense of those resources, we then take it to sources like CloudTrail or GCP audit log in order to figure out more information about when that resource was created, if it was ever suspended or resumed, just so you can get a better sense of the exposure window time frame as well. And then there's also configuration resources available from both Google and AWS that give you more sense of like how the resource changed over time. There's also the outside piece, right? So inside's great, source of truth, right? It's what's actually running, it's how it's configured. But we don't actually know, like, is it routable? Like, can someone actually hit it? And so that's where Nmap comes in. We do an actual scan with Luminat using Nmap in order to like try to talk to those specific ports and answer the question, like, oh yes, this is routable, and responding back. We also use WhatWeb. How many folks have used or seen WhatWeb before? Yeah, this is relatively new. There's just a couple of hands. It was new to me in this project as we were doing research. Really wanted to have fingerprinting of HTTP services. And when we came across this, I was so happy because it fingerprints like 1,800 different web services, and we didn't have to build that database or those detection rules or anything like that. So WhatWeb is great, and we'll show a little bit of that later. And then, of course, querying Shodan for context on the services it's found and also vulnerabilities that it's aware of. So as mentioned before, it is configurable, but configuration is not required. It has support for allow listing only in AWS right now. We're working to bring it to GCP. And then it reports to the terminal. That same information also goes to HTML because terminals are ephemeral and line wrapping gets weird. There's also a JSON payload, so you can parse it to your heart's content, and a CSV timeline so you can get started building out your timeline for your investigation. Here goes a demo. We'll see how Wi-Fi wants to play with me today. So here is the help information. No tool is complete without ASCII art. And here we've got the option to provide a configuration. I've got one preloaded here for BSides. And I'm going to go ahead and hit go. See the demo gods want to play nice. Hey, it's scanning, great. So it's starting to scan AWS and starting to enumerate some of the public IPs. From there, we'll move on to Google Cloud. And similarly, we'll identify public IPs and associated resources. And then once it has a sense of all of the public IP addresses in the cloud environments, it'll switch over to start running the tools on the outside, like Nmap, WhatWeb, and Shodan, in order to start answering questions about those and produce output. I'm going to switch over to our screenshots here, just in the sake of time. So here is what one of the entries looks like. I'm going to show you multiple screenshots from the terminal. Just hopefully this is readable. So IP address is the first thing, as well as the region it was found in. So you can scan multiple regions. We then see the network interface associated with it, along with the security group and the permissive rules. So here, it's filtering out any of the internal rules, so that way you don't have to go through a massive list. You're just focusing on the rules that are exposed to external IP ranges. So in this case, we see 80 and 8501 exposed. And we also see a load balancer attached, but it's only listening on port 80, and it's called Honeypot ALB. I know it's kind of hard to read in the font here. So interesting, like we got a little bit of information. Someone called this a honeypot. Neat. So here we have AWS config and CloudTrail. AWS config pulls back a lot of information, and we haven't figured out how to nicely display that in the terminal, but it all goes into the JSON report, so it's all there if you want to parse it out. And honestly, it's easier to look at it there because in the web app, it takes a little bit of time to load and query, so we've pulled it out for you. And then in CloudTrail, this is nice to see in the terminal, but the line wrapping doesn't really work great. But you can see like what CloudTrail's pulled out, so security group rules changing, resources being created, and so on. It's much easier to see as a timeline. I know this font's smaller for you guys, but like it's nicely structured for the timeline here and answers those same questions.
One thing.
Yeah, go ahead.
One thing we wanted to call out too is while we were building out this timeline, it's great to see that a security group was created, but what weight does it really have unless it was attached to your running resource? So we made sure that that information is built into your timeline as well, so that you have a full, exposure time frame.
Yeah. So here we have the outside tools. We have Nmap telling us for sure that they can reach port 80. We then have Shodan also confirming port 80, and here finding 62 vulnerabilities associated with the service running on port 80. So that's a good stat to start with, and gives us a chance to start running down what these are. Anyone recognize any of the CVEs in this list?
Some old ones.
Yeah, some old ones in there. It also calls out 443 and a Splunk server. You'll notice that 443 wasn't in the list in the cloud environment, right? So looking at the date here, this as of, we can actually see this comes from an older scan from Shodan. Shodan's not live data. And so in this case, it's showing us something that's slightly inaccurate. So always validate output from tools, right? Make sure all your sources are reporting things accurately. So the Splunk Cloud is probably also unrelated here. Here's WhatWeb. It's not the best example of WhatWeb, but it's showing that it's detected Apache. Notice that there was actually a redirect, followed the redirect, and is now saying, oh, this is actually a Synology disk station. I mean, it's not because it's a honeypot, but it's pretending to be. I just wanted to show off briefly the Google Cloud output. Very similar, shows the compute resource, firewall rules, and these are events from the audit log. This is the Google Cloud run service, which is the container run service that they have. And what you'll notice is instead of an IP address, it actually just shows the URL. And then under ingress, it says ingress traffic all. So the firewall rules are a little bit different there, but Luminance supports the URLs and will also scan those against, or scan those with Nmap, Shodan, and WhatWeb, so that way you get information on those URLs as well. This is what the config looks like, and this is what we were just running in the demo. So you'll notice you'll be able to set up which reports you want to output, as well as configure your tools. I did redact the API key. I trust y'all, but not that much. And we have the AWS and GCP configurations off to the side as well. These are the policies that are needed. This is also documented on our GitHub. And as you'll notice, they're all just read policies and rather short lists that hopefully are easy to share with the administrator of the cloud environment for them to set up a role for you to run the tool. And that's it. Let's see actually if the demo finished. Hey, it finished. Great. Yeah, any questions? They're coming with the mic. Yep.
Is Azure on the roadmap?
Azure is on the roadmap.
Sure is.
Yep. If you have Azure expertise, we'd love to chat, because that's an area that we don't. Other questions? Oh, one over here. We had time.
Thank you for the talk. The question is not really related to the tool by itself, but more about attacker on cloud. Are you seeing a difference today with attacker trying to use the cloud as a pivot point to compromise the on-premise, or they usually just stay at the first layer of resources, trying to deploy crypto miner or things like that?
Do you want to take this?
Yeah, sure. So generally what I've been seeing, it's kind of staying at that cloud level. I haven't seen an instance where they're using cloud as a pivot point to get to on-prem infrastructure, only because I just haven't seen that exist in my line of work. I'm not saying it doesn't happen, because it's very possible to do. But generally, like the day-to-day, the compromises that we're actually seeing are some of the commodity malwares or the crypto miners. That's what we're generally seeing, unless it's something that's more of a high-value target. So if it's critical infrastructure, if it's something that's like more of a weighted value, that's when we're going to see the more sophisticated attacks, where potentially APT-type attacks may be a little bit more sophisticated, where it's targeted. But generally, it's going to be more of those commodity malware, crypto mining that stays in the cloud, tries to look for pivot points, but it's probably going to be at the cloud for the most part. But to answer your question, I haven't seen it. Not saying that it doesn't exist, because I'm sure it does.
I can actually give an example. So I work very few cases these days, as I'm mostly on the developer side, but got called into a case in the past year or so where we did see them pivot, not necessarily on-prem, but multi-cloud through our favorite service, Jenkins. And so that was an interesting one. I can't talk more about it, but.
And does your tool detect any EIM exploitation or EIM weakness that can allow an attacker to raise its privilege on the cloud environment, or detect some access persistencies, for example, backdooring a specific role, opening the AWS account on another account, or it's not something implemented yet?
So the question was about IAM and using that for persistence and such. Am I getting that right? Okay.
EIM for persistence, or attackers that are using EIM to escalate privileges,
Gotcha.
things like that.
Do you want to speak to that? Or?
Yeah, that's not something that the tool currently supports,
Yeah.
but I think that's a pretty valuable resource to start enumerating into. Like we have the infrastructure, like the actual networking component, and that's the privilege escalation part that we aren't necessarily looking at. So I think that's a good pivot point for future movement of the tool.
Yeah.
Yeah.
Thank you.
Thank you.
Yeah, thank you.
I think we're at time, so yeah, thank you all. Appreciate it.
We'll be around if you have any other
Yes.
questions.
Thanks. Good job.
Testing.
Test, test.
Oh, yours is good. Mine might need to come up. How's that? Test. Test. And the PC audio is on too? The computer audio? Cool. Let's see. Yep. Yeah, I know. Yeah.
If it gets too loud, we'll leave it at volume at this level. So we're down one bell and drop volume. Just over by the soundboard on the desk. Sure. Check. Check.
Yeah, you're good, man.
Good evening, everybody. Welcome. Welcome to B-Sides Las Vegas, ground floor. So today we're going to have the talk, Don't Be Lame, the basics of attacking LLMs in your red team exercises. And we have our speakers, Alex Bernier and Brent Harrell. Before we begin, a few announcements. We'd like to thank our sponsors, especially our diamond sponsors, Adobe and Aikido, and our gold sponsors, Dropzone AI and RunZero. It's their support, along with our other sponsors, donors, and volunteers that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask you to check to make sure your cell phones are set to silent. If you have a question, you'd be using the audience microphone that I'm holding right here so that YouTube can hear. And if you have a question, please raise your hand so I'll bring the mic to you. As a reminder, the B-Sides Las Vegas photo policy prohibits taking pictures without the explicit permission. These talks are all being recorded and will be available on YouTube in the future. So if you're in the room, please move forward a few seats to let those who come in grab the seats behind you guys. With that, let's get started. Please welcome our speakers.
Good afternoon, good evening, everybody. I'm so excited to be back here at B-Sides. I was here 2 years ago talking about a red team maturity model. Today, Alex and I have a different kind of model for you. It's this little-known technology. Not many people are talking about it. We really think it's going to change the world, though. It's these things called large language models. Now, obviously, I don't have to tell anyone that LLMs are all the rage right now. There's a lot of great content and sessions this week. I'm excited about a lot of them. But for red teamers in the security field, there can often be some confusion or maybe even intimidation around how do we engage with this technology as part of our red team exercises. And I think that confusion stems from two areas. If you look at how red team is discussed in Gen AI spaces, there's, in many cases, a heavy emphasis or an exclusive emphasis on safety and ethics stuff. making sure it doesn't tell you how to build a bomb or doesn't behave in a racist or sexist or biased way. And don't get me wrong, that's really important. We don't want an HR bot to filter out candidates because they're over 40, like happened a month ago. But I think most of us in this room would say, okay, yeah, that's a problem, but it's not my problem. Where's the real security impact here? I think the other source of confusion can be how a lot of the material thus far has focused on the LLM itself. So things like prompt injection and jailbreaking, and that's kind of where it stops in many cases. So again, we end up in two scenarios here. One, we get it to say something dirty. Okay, so what? What do I as a red teamer do with that to achieve my operational objectives? And two, focusing on just the LLM can make it seem like an AI problem. And really, we do have a security problem here when we start to turn these things into agents. So I don't want to go on a side tangent on whether or not the definition of red team in Gen AI is being used appropriately, but I think we can at least say that there's kind of a mismatch in the definition right now. And when we talk about things from a security perspective, we're talking about simulating an adversary trying to achieve some sort of malicious impact in an objective-based exercise. So when Alex and I talk about red team today, that's what we're talking about, not necessarily the safety and ethics stuff, although as we'll discuss in one example, there can sometimes be overlap. Now, the other thing that we're going to do is we're going to focus heavily on the systems that use these things because the applications and agents that are employed by these LLMs are a lot more interesting from a security perspective. Focusing on just the LLM leads to some shortfalls and some lack in security. It just doesn't fit nicely on a title to say that applications and agents based on LLMs in your red team exercises, right? So, all that said, what are we going to talk about? We've got a little bit of theory here on how LLMs work under the hood. This is 15-ish minutes on what we think you as red teamers should know about what's actually happening inside these LLMs so that you can understand the attack paths. Because this is really the engine that drives this car. It's what makes these applications different from other things that you're used to attacking in your red team exercises. Now, there's no prerequisite knowledge. There's no math, so don't worry about that. Daddy's got you. And then when I'm done, Alex will pick up with the attack side. And yes, we will talk a little bit about prompt injection and jailbreaking, because that's usually the entry point. But we're not going to stop there. We're going to take that into how do we get into the impacts that we as red teamers want to see. The attack tactics like execution and lateral movement and privilege escalation and discovery and credential theft, all these wonderful post-exploitation things we go after, we've been able to accomplish most of those things in our exercises with the apps and agents that exist today. So a little bit about us. My name is Brent. I'm a principal consultant at CrowdStrike, along with Alex, who's also a principal consultant there. We're part of the professional services red team, which is the consulting side of the red team. We're two of the founding members of the Gen AI red team there. And I get all that up front just to get to the disclaimer that our opinions are our own. We're here as ourselves today. If Alex says something stupid, it's his fault. If I say something stupid, it's Alex's fault. But in any case, it's not CrowdStrike's fault, all right? My background's more in traditional AD enterprise exercises. I had actually started outside of technology, but as I worked my way into security, that's kind of been my bread and butter. And I think that's probably the case for a lot of folks here. And that's why I'm really excited about this topic to help bridge this gap. Because I've had red teamers tell me, well, I'm not an AI guy, so I'm just going to stick with ADCS, or what's the big deal with prompt injection? And Alex's background, he came from the blue team side, and he also is really heavy into the web application side, where, again, LLMs have a lot of juice as these things are being plugged into chatbots and a whole bunch of other applications. So let's get into how these LLMs work. And again, I promise you this will be painless. So inside of artificial intelligence, you got machine learning. Inside of machine learning, you've got a bunch of different subfields. The one that matters to us is something called deep learning. And deep learning really excels at unstructured data, things that we can't programmatically say, hey, these 6 boxes are checked, therefore it's this thing. That's why it's used in robotics, because the world around us can be pretty random at times, right? It's also used in LLMs, because even though language has rules and grammar, we can manipulate those rules to emphasize different things and structure sentences in different ways. And so it's not deterministic. It's very unstructured. And this deep learning process works with a special computing structure called a neural network. Now, you've probably heard of these before, but we're going to talk about this just a little bit, because there's some important implications to when we get to the LLM side. Now, these neural networks are comprised of thousands or millions of these little things called neurons. And these neurons are arranged in a bunch of these layers of groups. And these all tied together by these little lines that you see up here that are called the weights. Now, what are the neurons? They're basically just data receptacles. They hold a value, and that value is called its activation. And that activation is how present or absent that piece of information is that this neural network is operating on. Now, the easiest way to understand that, I think, is in the input layer. Whatever we're feeding into this, whether that's text with an LLM or images with an image classifier or something along those lines, that first layer, we're going to map that data into these neurons. And that activation value is going to correspond to the different pieces of it. So for on the next slide, I've got an example of image recognition where those are going to tie to pixels in an image. Now I'm going to skip over the hidden layers here for just a second and get to the output layer, because I think that's the next easiest thing to understand. And if you take away nothing else out of this slide and the next slide, understand this. The output of a neural network is a prediction. It is a bunch of math that creates a probability. It is not like putting something through a Python function where if you give it the same arguments, it's going to have the same result on the other side of the function. It's math. That's why you see a little green box around images in a video that says like 99.9998% confidence it's a human. It's pretty confident, but it's not 100%. So this output layer is going to account for all the things that this neural network knows how to predict, and it's doing that in a probability. Now these hidden layers are where the real magic happens. This is where deep learning takes over. Neural network designers can set up the number of neurons, the number of layers. They can do all that, but they often don't tell the machine what to do with those layers in the middle. That's where deep learning decides, hey, I'm picking up on these patterns. I think this will help me predict things better in the future if I do it this way. So these hidden layers are really important, but that's also where we get to kind of the black box nature of machine learning models. Now, the weights. These are the core of the model itself. You can set up the neural network with the same number of neurons, the same number of layers. If the weights are different, it's going to behave differently every time. And what these weights are is really just a relationship. It's a relationship between each and every single neuron in one layer and its neurons in the next layer. You're going to have a line between each of them. And it's a relationship that says this neuron has this amount of importance to this neuron in the next layer. And that can be positive or negative. So in a really basic example, let's say you've got temperature on one side, and you've got the probability of ice on another side. Well, that's going to be an inverse relationship. As the activation of that temperature, the temperature rises, ice is coming down. There is no ice outside in Las Vegas right now. Let's say it's sweat instead. If the temperature rises, that's a positive relationship. You're probably going to be sweating out there because it's really hot. So these weights are really important, and they just dictate, hey, this neuron, it matters to this next neuron in the next layer. Now, let's give this an example here to hopefully illustrate this a little bit better. I think the easiest example, even though we're talking about large language models today, is image recognition, because people visualize things. So let's say we want to take some handwritten notes and convert them into searchable text in your favorite text editor. Well, we're going to need some machine learning there with optical character recognition, because everyone's handwriting is different. You can't just say, hey, these blocks are filled in, therefore it's a B. This one's a bit slanted. Some people write cursive, et cetera. So if we were feeding this into a neural network, let's just say we're keeping things simple. We scan this document in, and we break it up into these little 20 by 20 pixel grids. And somewhere in there, we're hoping is a letter that we're going to pick up. So that means there's 400 pixels in this image. So our input layer needs at least 400 neurons, one for each of these pixels. And that initial activation value in that input layer is going to correspond to the presence or absence of ink in this very simple case. So if it's the background color, white, it's not activated at all. There's no data there to represent, so we'll say it's an activation of 0. If it's fully pitch black in the middle of that B, it's full of ink, so we'll say it's strongly activated at a 1. And then you'll get to these edge cases where the ink maybe bled into the paper a little bit, or you've got a smudge, and you'll have these values between 1 and 0 that represent some sort of gray tone in there. So that's the activation for the first layer. How do we get the activations for the rest of them? Well, I promised you no math, so if you want to see it, it's up there in the yellow. But basically, we're going to do a lot of multiplication and addition for each and every single one of these neurons with their weights. And again, if these things have thousands or millions of neurons in them, we're talking millions and billions of calculations just to get through one run of this neural network. That's where a lot of this computational power is required. So the hidden layers do all the magic. We talked about the machine picks up on things. Now, they're not human. They don't think like we do. But how would we recognize stuff? We'd start to recognize edges. Okay, so the machine might pick up, there's some light pixels next to some dark pixels. That might mean something. And then we can turn those into lines and lines into shapes. And we get to the output layer where then we can take those shapes and turn it into letters that it has been trained on. So once we get to that output layer, again, it is a prediction. We're going to do all that same math to calculate the activations. We're going to do a little bit more math to make it a probability, because you can't have more than a 100% chance of something. And then that's going to tie to what it's been trained on. So in this case, if we trained it on English, it'll have a neuron for A through Z, upper and lowercase, letters, numbers, any special symbols that you want to take care of. And if you want to add other languages, it would have those outputs as well, based on what you're training into it. But again, the key takeaway is that this is a prediction. It is a bunch of math that happens to get to a chance of it being something at the other side. And if you remember your middle school or high school algebra, you probably got the wrong value for x somewhere along the way. And your answer was what? Wrong? It was wrong. So that's what we're trying to do as we're attacking these machine learning models. Can we slightly adjust some of the variables like x in here to get it to predict something that maybe we want instead of what it should have been predicting in the first place? So what the heck, Brent? This is about LLMs. You just talked to me about neural networks for 10 minutes. Well, that's because the key architecture underneath a large language model is a transformer. And a transformer uses these neural networks to do its job. It's also really important to understand from this discussion of neural networks that LLMs are just doing prediction. That's what it is. It's not a deterministic output of text. It is working on math and numbers, not language, despite language being in the name. So as we transition into discussing these LLMs, I thought we would start with a funny video, or at least I think it's funny. If you don't, the door's over there. But I really think it's a great illustration of how these LLMs work, completely agnostic from technology. So this comes from a comedy show called Whose Line Is It Anyway? If you didn't have the fortune of seeing it on TV when it aired, it was a bunch of comedians. They knew the rules of the games that they were playing, but they didn't know what they were playing about, the prompt, so to speak. That was given to them while they were recording the show by either the audience or the host. Now this particular game is called Three-Headed Broadway. And in this game, they have to create a song, but the catch is they can only say one word before it moves to the next comedian. So if you know a little bit about how LLMs work, you see where this is going. But we're going to watch this video and then actually use it as a way to talk about some other important concepts. So let's give this a go.
You are my soul mate. I can't hardly believe. Gesundheit. Can't love me.
All right. Hopefully that was enjoyable, but there's actually some really good concepts that we can take out of this. So the same way that these comedians are generating the song one word at a time and they don't know what the final result is going to be, LLMs are generating their output one token at a time, and they have no concept of what the final answer is going to be. They're just going to predict that token until they get to a point where they think, I've answered the prompt. So the key word here, though, is tokens. We as humans, we use language. They're using words as comedians. These LLMs are using tokens. Now, tokens can be whole words in language, but they can also be punctuation and differences between uppercase and lowercase letters. It can even be characters that we don't really recognize as language if it's been included in its training set. So there's a lot more that's going on, and they're doing this with numbers instead of actual words. And we can see kind of an example of this from the video where we get to this first part, you are my soul, and Drew, the guy in the middle, adds the word mate. Well, in English, soul and mate are both individual English words. Soulmate is also a single English word. There's no space, there's no hyphen. That's kind of an example of how tokenization might work. The LLM might, through its learning process, decide to tokenize something slightly differently and put tokens together into what we would recognize as a single entity. Now, how do the comedians know what to say next? Well, because they're paying attention, right? They're paying attention to what they've said before, what their colleagues have said before. So we get again to this part, you are my soul, and Drew, the guy in the middle, is like, yeah, that doesn't really make sense, so what can I do to that? Oh, I'll say mate. Soulmate makes more sense, right? Well, why are they writing a song about a shoe? That's kind of weird. Well, they're paying attention to the prompt that they were given as well. So LLMs, through the transformer, have this attention mechanism where they are looking at what's come before to figure out how to continue to make it make sense. But they're also looking at other data that's being fed into that. the system prompt, the user prompt, outputs from tools or RAG or anything else along those lines, that's all getting considered as it's doing its math to predict tokens. Now, the last thing that we can see on this slide, and I've got time, so I'll talk a little bit about it, is hallucination, right? That comes up a lot. Hallucination is a feature. It's not a bug. LLMs are incentivized to predict tokens. That's what they do. And they don't really know facts. They know patterns. And sometimes those patterns can be facts based on the training data that they've seen. But really, a hallucination is just a bad series of token predictions. It's stuff that doesn't tie to reality because it doesn't know what reality is, or because it predicted a bad token once, and now that's part of that attention mechanism, and it just starts to spiral and go off the rails. So we can see hallucination in the video there, where Wayne, the guy on the left, accidentally says 2 words. It confuses the guy in the middle, who just kind of says, ooh. And then Ryan, the guy on the right, being funny, says Gesundheit, which is bless you in German, because it kind of sounded like he sneezed, right? That's a perfect example of hallucination, but it's not that these LLMs are trying to lie to you. It's just how they work. So GPT for all. You've heard GPT in the name of ChatGPT. It's there, but if you weren't aware, this underpins pretty much every model that you're going to see today. Generative pre-trained transformers are in Claude, they're in Mistral, they're in Cohere, and Llama, and DeepSeek, and all those things. Now, generative makes a lot of sense. We'll skip that. We're talking about generative AI. Pre-trained means it's gone through that deep learning process. And in the deep learning process, it's used those neural networks, and it's tweaked all those weights so that it can make the right predictions on the other side. But another key element of training in this case for the LLM is it's also going to create its dictionary called the embedding matrix. Now, this dictionary is the series of all the tokens that it knows based on the input data that it's seen. So it'll go through a tokenizer, and then it'll create these embeddings, which are long vectors of numbers. Now, this audience is probably more familiar with the term array. It's similar. It's a long series of items where the indices can be individually accessed, and they have their own meaning. Well, in this case, during the training phase, as it's tuning all those weights, it's also trying to understand what these tokens are through this embedding matrix. And these indices are given some sort of value or meaning by the machine, where one index might represent bigness, and another index represents friendliness, and another one represents blueness. And that's how it's trying to understand language. It doesn't do language like we do. It does it in numbers. And that's where we get to the transformer. This is the pivotal piece that really changed how LLMs have taken off over the last several years. And this transformer is grossly simplified here, but it uses those neural networks that we talked about before. And it adds to that these attention blocks that we're going to talk about here in a second. But with the transformer, it's still a prediction. You take input text on one side, you do a bunch of math and calculation in the middle, and then you come out the other side with a predicted token, or a sequence of predicted tokens, and it figures out, based on temperature, which one it wants to go with. But this attention mechanism is key. This is what makes these LLMs seem so smart and so good at their job. How do we as humans know what the definition of bark is in those 2 sentences in the top right? If I just gave you the word bark, you wouldn't be able to tell me the answer, right? You understand it because of the context. The dog, okay, that's a sound. The tree, okay, that's a physical material. Well, LLMs have the attention mechanism inside the transformer to do exactly that. To look around at all these other tokens, to ask questions of what are you? Oh, you're an adjective. Okay, that means a noun should be coming pretty soon here. They're just doing it in numbers. It's not language, it's numbers. So they'll take all these words, all these tokens, convert them into those embeddings that they've seen, those vectors, do a bunch of math, and calculate this new vector and say, okay, in my embedding, or in this case, the unembedding matrix, my dictionary, which token that I know about is closest to this number that I've just calculated. That's what's happening. It doesn't understand language the way we do. And this is where we can start to do some attacks, because if we can change the math along the way, it doesn't understand language like us, so we can potentially manipulate the output, the mathematical equation, by using uppercase characters instead of lowercase, because it might interpret that differently. Now, we're almost there, I promise. The last bit of theory here is the context window. This attention mechanism is key, but it's also subject to compute power. These LLMs can't constantly keep everything in memory and work on all things at all times, right? This is why we take tons and tons of GPUs, because there's a finite limit to how much it can look at, and that's called the context window. And if you've used ChatGPT or some other LLM product, you've probably noticed that if you ask it too many different topics in a single chat thread, it starts to give you really crappy answers. Well, that's because it's trying to pay attention to too many different things in this context window that you're giving it. And you're better off starting a new thread. Because now the context window is clean, it's not trying to pay attention to any of those other things, and it can focus on the task that you've given it. Well, this context window is limited, but it also gives us opportunities to do attacks. Things that Alex is about to talk about here in a second, like confusing the LLM intentionally, changing the topic, changing what you want it to do to maybe get it to forget its rules, or pushing things out of the context window. So for example, I think GPT-4o Mini right now has a context window of 128,000 tokens. So if we give it really long documents or a really long conversation thread, at some point, something's off the island, right? And if you built your app or your application poorly, that could potentially be your system prompt too. Not likely, but that's possible. So now we get to the fun stuff, right? This is what we're here for as red teamers, breaking things. And I've got one more slide for you before I hand it over to Alex. Kind of the so what, right? As we've gone through this discussion on how these things work, hopefully one of the things you've picked up on, in addition to it's all math and probability, is that these LLMs just generate text. That is all they do. Have you heard me mention executing code once? No? It's because they can't. LLMs by themselves just generate text. And that's what leads to some of the confusion for red teamers, I think, is if we only focus on the LLM, okay, so what? It outputs something dirty. Who cares? I can't do anything with that as a red teamer to get to my objective. Or, to make it even better, ChatGPT, Claude, Gemini, all these things, they don't know anything about your company. If it wasn't in their training data, they don't know your product secrets, they don't know your source code, unless you leaked it online, in which case you've got a different and bigger problem, right? So even if it did generate something dirty, it's not going to be a security impact. And that's where we start to transition into the applications and agents that are using these LLMs. The LLM drives it, but it's really these applications and agents that give us, as red teamers, a lot of capability. And one of the biggest steps towards that is tools. Tools are just functions that we've written, or through the model context protocol, you can even access functions that other people have written. But this is just regular code. It could be a Python function like check weather and gives it a weather API. Tools are what give LLMs the ability to act. By themselves, they can't do anything other than generate text. But even still, the LLM can't call the code itself. It just is told about the tool and says, oh, I would like to call that. So what we do with this is we write a function, let's say check weather, and then we send a prompt to the LLM, hey, what's the weather in Las Vegas, Nevada? And we also send a description of this function. Here's what it does, here's the name of it, here are the arguments you would need to provide, here's what you get back out of the function. And so we send that along too, and the LLM in its context window sees that and says, oh, I don't know what the weather is because I just generate text. But I see I have a function here called check weather, and that I just need to provide the city and state, and it said you were in Las Vegas, Nevada. So, hey, application, call this function check weather with Las Vegas, Nevada as the arguments. And so the function, the application, will go run the code for the LLM. It'll return that back to the LLM, and the LLM can then render its final answer. It's really hot, right? Well, as red teamers, what does that give us? That's execution. It's running code. It's potentially privilege escalation. Have we seen service accounts in the domain admins group before? That doesn't happen, right? Of course it happens. What do you think happens here? If these LLM applications and agents are given more permissions than the user does, and you don't lock that down, you've got privilege escalation, because now you can run things that you shouldn't be able to run by controlling the LLM. And then we've got pretty much every other attack post-exploitation tactic that you can dream of based on the tools that you're giving this LLM. Now the other side of this, I mentioned a moment ago, ChatGPT, Gemini, Claude, et cetera, they don't know anything about your company. So if you ask it, hey, how many days off a year do I get? It'll say, I don't know, general HR policies say you should get 15 days off a year. Hopefully more than that, but we'll say 15. Well, what would you do here? This is something called RAG. Now we can give the LLM access to other information that's specific to the task that we want it to work on. In this case, we would give it access to our company's HR policies. So that if an employee comes in and asks how many days off a year I get, it can say, well, according to HR policies, you get 15 days a year if you've been here 3 years or longer. You can combine that with tool calls, too. You could have it call out to your HR management portal and say, oh, you've been here 3 years. According to the HR policy, that then means you get 15 days. Well, that sounds a heck of a lot like getting access to a file share, right? or a SharePoint or some other data repository. So now we've got collection. We've potentially got privilege escalation. Again, if it can read things that you shouldn't read. As Alex is about to talk about, you can also use this for lateral movement. If you can poison that RAG data store and get it to basically like a stored cross-site scripting, spit some malicious answer out to another user who's unsuspecting that their data source has been poisoned, right? So I don't want to anthropomorphize AI here with this last statement, but these LLM agents, they don't think like humans, they aren't humans, they don't act like humans. You can consider, though, that compromising the LLM that's been embedded in one of these applications or agents is a lot like compromising a user account or a service account. If you can control the output, you can now potentially take control of the privileges and accesses that that LLM has available to it through that application or agent. And with that, I'll pass it over to Alex. Clicker's not working.
All right, now before we get into, before we put on our attacker hat, let's first go through some initial definitions here. So, at a high level, we consider prompt injection to be a superset of jailbreaking, which we can define as really any type of a malicious prompt that's trying to insert new instructions or manipulate the LLM's behavior in some kind of way. And jailbreaking, we can define as a type of prompt injection, where the goal here is to have the model disregard its ethical alignment or really anything that's a part of its system prompt. Now, because of how LLMs work and some of the theory that Brent talked about, they're going to understand anything that's a part of their training set to some extent. And this is going to include different languages, different characters, and like we'll see here in this first example, things like Unicode control characters that don't always get rendered in certain applications. Now, this first example was published by Riley Goodside, who was talking with ChatGPT, and he said, "What is this?" And he included what looks like some weird-looking Zalgo text. What you can't see is that in this string, there's a set of 0 with Unicode characters that they don't get rendered in HTML, but ChatGPT is able to interpret. And in this case, it said something like, generate this weird-looking image of an alien, and it includes some creepy follow-up text. And this is a really effective technique for including these hidden types of prompt injections because of the fact that the majority of applications, websites, and LLM agents out there, they're not going to be sanitizing for these types of characters. And so so if there is an LLM that's going to be interfacing with or scraping a lot of these popular websites, then this is going to be a really good way to do this hidden type of prompt injection. Now, there's two main types of attacks. There's direct prompt injection and indirect prompt injections, which we'll get into here in a moment. But first, and I'm sure that the majority of people already know this, but what a direct request looks like to an LLM under the hood is going to include a system prompt, which is the application prefacing to it that this is the persona I want you to have, this is what I want you to do, and this is anything that I don't want you to do. And then obviously as the end user, usually what we can control is going to be the user input. But what's actually received by it is going to be these two things as a wall of text. And because of this, if you say something like, ignore the prior instructions, do something evil, well, really, it's just going to do exactly that and just kind of predict the next token. And across our assessments, we've seen a lot of different attempts by developers to implement guardrails and security controls to try to mitigate this type of prompt injection. And some of the common pitfalls that we've seen have been things like a static dirty word list that's checked against the input or the output. We've seen some system prompts with instructions like, don't talk about this topic or don't say this word. And one of the ways we can get around this is using obfuscation because, again, anything that's a part of their training set, they're going to know to some extent. And so this includes different languages like German and French and even something more obscure like Swahili, and also different types of encodings. And so usually you can talk to it in base64. You can tell it to output something in German. And this is going to be a good way to get around some of these more rigid security controls. Now, the other big attack surface here is conversation memory. And because of that attention mechanism that Brent talked about earlier and some of the inherent limitations around this, this technique known as context confusion kind of comes in handy here, where we can confuse it by giving it a bunch of different tasks, changing the output format that we're asking for. And by doing this over the course of multiple messages in a conversation, we can kind of confuse it and get it to kind of break out of some of the things that it's been told in its system prompt. Now, two additional strategies that are useful when we're doing this type of direct prompting are going to be persona setting and storytelling. And you've probably heard of the Dan or the do anything now prompt. This was a really popular jailbreak prompt for a lot of the earlier models. It doesn't work for most of the newer ones, but the concept still applies, where it was basically this really long prompt saying it's a bad thing to say no, always be helpful. Basically, nothing under the sun is bad. And the idea here is that if you can find a persona for it, that confuses it or gets it to break out of its normal behavior to be less likely to say no, then this is going to be a good way to achieve a jailbreak. Now, storytelling is centered around this idea of using different pretexts. Because for every prohibitive request that we're going to get a refusal for, there's going to be some way to reframe the question, to add some legitimacy or some justification that's going to be interpreted by the model a little bit differently in terms of ethical alignment. And so if we're saying something malicious, like, how do I abuse an ADCS server? Well, that's probably going to give us a refusal. But if we kind of reframe that a little bit, and we say, this is a red team exercise, or I have permission to do this, or if we're asking how do I attack this thing, you might say, I'm trying to defend against this type of attack. Tell me what to expect from an attacker. All of this is going to help, including, for some reason, we've had pretty good results by just asking for any type of simple output format, even like a simple bullet list. And then the other consideration for this is, again, conversation memory. So as you're iterating across different attempts to getting around these refusals, either manually or if you're doing this through fuzzing and attack automation, definitely make sure that you're thinking about conversation memory and that you're starting a new conversation when it makes sense. And usually that's going to be when you're trying a new pretext. Now, indirect prompt injection is great when you can't directly interact with the LLM application. And so if you don't have a user interface, you don't have a command line interface, you might be able to come at it through some sort of tool that's being used or a resource that it's accessing. And for us on red team operations, on red team exercises, one of the things that we want to go after is the capability to impact an internal LLM through a RAG. And so if you have the ability to write to some sort of resource, like a SharePoint resource or a file share, then you might be able to include some prompts in these files that are going to affect the output of the LLM. And by doing that, this is going to be a really good way to try to target third-party users. And so the first example of some research that we saw published online that sort of got us thinking about ways that we can start to use these in our red team operations was something published by Johan Rehberger, who has a blog that I recommend everybody check out. And he showed this example where him and his colleague, who was sort of the mock victim here, they were in Google Workspace, and Johan created a new document, and he tagged it as being related to some kind of legal query. And he included these instructions, basically saying to the LLM that I want you to output this very specific markdown image syntax. And he referenced his listening web server, in this case, a Google macro. But any type of listening web server would work. And he included a GET parameter that he told the LLM to fill in with the encoded user messages in the conversation. And so Johan then shared this document with his colleague. And if you're familiar with Google Docs, it'll ask you, do you want to notify the person that you're sharing this document with that they now have access? And to be just a little bit more stealthy, uncheck that box so that his coworker wouldn't be notified of this. And so his coworker then had access to it. And because of the fact that they were using Bard for their RAG, and it was going off of his account's permissions and what files that he had access to, any time then that his colleague would ask some kind of legal query, this prompt would be interpreted through the RAG. It would output that markdown image syntax, reaching out to Johan's listening server, exfiltrating that conversation history. And so indirect prompt injection is going to be something that we'll be continuing to use pretty frequently for our red team operations. And so definitely keep this in mind, because if you are on a red team op, if you do have the ability to modify a knowledge base in some kind of way, then this is going to be a good way to target users and to also do this type of data exfil. So that was a quick rundown of some of the prompt injection strategies. But as Brent mentioned, we want to really go one step further and really kind of drive home how you can have some real impact with some of these. And for traditional operations, we usually try to accomplish a bunch of different MITRE attack tactics. And we've been able to use almost all of these for post-exploitation to get to our operational objectives. And for some of these, like we'll see here in this first example, which is of credential access, you don't even really need to use prompt injection to do this. Now, this first one was where a buddy of ours, he found a Slack token, and he didn't know the account's password. He didn't know the NT hash, so he was kind of stuck on Slack. And he did some initial recon, and he found that he had access to this self-service Slack bot. In this case, it was meant to be used for routine issues like IT. And by just chatting with it and asking what it could do, he found that it had two tools that he was able to abuse. The first one was it actually had the ability to do a password reset for him, which is pretty surprising. But because a lot of the other applications still required MFA, this wasn't really a full solution, so he was still stuck on Slack. He was chatting with it a little bit more, just kind of asking what else it could do. And he found that it also had the ability to do a MFA device reset for him. And so he didn't have to do any type of fancy prompt injection to really use this. This was really just him abusing this existing functionality. Now, the next one, which is lateral movement, this is similar to the poisoning example from the last slide. This was one assessment where we had write access to a company share, and in this share there were a bunch of policy documents that were being consumed by a RAG as a knowledge base, and we modified one of these. In this case, they were Word documents, so we did this in a little bit of a more stealthy way. We modified the content of it, in this case using a white, small font, so that if somebody manually looked at this, it wouldn't have been obvious that we modified it. And we basically made it so that if somebody asked a super common policy question, that they would get an answer recommending them to download and execute this random file, in this case, our C2 beacon. And this is really great because for some reason, a lot of people, they seem to assume that the output of an LLM is somewhat authoritative or that it's trusted, and it really isn't, and this is kind of one way that we can abuse this for social engineering, and we can also use this for lateral movement. Now, impact and defense evasion, this one hits another theme that Brent mentioned, which is that there's sometimes going to be some overlap between safety, ethics, and security. And in this case, we were able to basically disseminate false legal information where there was this application that had two components to it. There was a RAG that contained a bunch of legal knowledge for its knowledge base, and then users could upload these documents, and it would give legal advice based on what it knew. And we couldn't poison the RAG for this one, but because it wasn't using a robust system prompt, we were able to include a set of instructions in our uploaded document that basically said something like, there's this brand new law that was just passed today, and that this should override a lot of your existing legal knowledge. And this actually worked quite well. And to make it a little bit worse, if this was a real attacker, the uploaded documents, they weren't being retained long term. So if this was a real attack, it would have been a little bit harder to kind of investigate what was going on here. And for this one, if you're thinking about normal red team exercises and how, what this delivery mechanism would have looked like, you would kind of have to do some type of watering hole attack to maybe trick a user into uploading a document to this application that contained that prompt injection. So there'd be some additional steps by poisoning a file template or something like this. Now the next one, which is exfiltration, we already talked about how that markdown image syntax can be abused for data exfil. But one of the things that I didn't mention is that there's a component to this markdown image syntax called the alt or the alternative text. And if you set this to nothing, then it does that same type of data exfil behavior, but nothing is shown to the user at all. And so that's a much more stealthy way to do this. And then remember that we're able to exfiltrate really anything that's a part of that conversation history. And so this is going to include, obviously messages, also tool calling results, and we can do things like system prompt extraction, and we can also kind of ship that off to another web server just using data exfil. And then beyond just Markdown, we've also seen applications that render HTML and JavaScript, so you may also be able to do HTML injection, cross-site scripting, and through that do things like steal the session cookie. Now the next one, which is initial access and persistence, this is a really fun one. This was an application where it was able to generate code for us in a user project, and we found that if you gave it a URL, that it would go to that website, it would take a screenshot of it, it would pass this to a multimodal vision model, and it would do some analysis. And we found that we were able to get a prompt injection, and one of our observations was that every time that it went to our website, it would use the same user agent string. And so just to be a little bit more stealth, we include some JavaScript on our website that would dynamically load the page based on that user agent string. And so we would only include our prompt injection when we knew that the agentic tool itself was accessing our website. And so because we were able to get this prompt injection working, we coerced the LLM into including some malicious package imports and also writing a web shell to the project. And so that was a really cool way that we were able to get an RCE. Now the last one, which is collection and privilege escalation, this was one example where we were able to abuse this idea of excessive agency, which is any time that the application can act beyond the user's own permissions. And in this case, we had access to a file share, or to a SharePoint rather. We had access to this LLM application, and there were some SharePoint resources that we didn't have access to, but we knew that they had info that we needed. And so by simply taking those URLs and giving it to this LLM, we found that it was actually able to summarize those resources for us, and this kind of allowed us to collect the info that we needed. So I hope that those examples gave you more of an idea of some of the downstream effects that come from attacking LLMs, and that it really is a lot more than just getting them to say bad words. Abusing them is really just the start, and a lot of the real impact kind of follows behind it with the applications and agents. And even though a lot of the examples that we talked about today were of chatbots, remember that LLMs are constantly being used behind the scenes. And regardless of what type of application that you're dealing with, it might be interfacing with an LLM on the back end. So the next time that you're on a red team operation, definitely be on the lookout for LLM-based applications and agents. See if this is an attack vector that you might be able to target by being able to write to some sort of data resource or through direct prompting.
All right, that's it for us. Thank you, everybody. The slides. Thank you. In addition to the recording, the slides will be available on my GitHub there. So if you do want a picture of that, I'd give you my permission. And then we'll also be having a small CCF as part of a workshop at DEF CON, so the code for that will be available after DEF CON as well. So thank you for your attendance.
Thank you, guys. Good evening, everybody. Welcome to our last session. Welcome to B-Sides Las Vegas ground floor. This talk is going to be the last talk today in ground floor. And this talk is titled X's and OAuths, They Haunt Me. And it's given by Daryl, right here. A few quick announcements before we begin. We'd like to thank our sponsors, especially our diamond sponsors, Adobe and Aikido Security, and our gold sponsors, DropZone AI and Profit. It's their support, along with our other sponsors, donors, and volunteers that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, you would be using the audience microphone that I'm holding so that YouTube can hear you, and I'd bring it along if you raise your hand. As a reminder, the B-Sides Las Vegas photo policy prohibits taking pictures. Yes, so please do not raise your cameras to take pictures. It's not allowed unless you have explicit permission later. These talks are all being recorded and will be available on YouTube in the future. And if you guys have already settled in, please feel free to move forward to let space for others who are coming in. With that, let's get started. Please welcome a speaker again.
How's it going, everybody? End of the day, Monday, right? We're all feeling energized, right? I was on a plane for about 15 hours yesterday, so I'm in the middle somewhere, but we're gonna get through this and we're gonna have a good time, right? This is going to be about cloud security, cloud authentication and authorization, some of the differences between OIDC and OAuth 2.0. So who am I? I'm just a guy. Currently, I'm a solutions architect for Netrix. Work a lot with Pingcastle, a lot of the old stealth bit tools and stuff like that. So everything from endpoint security to network security, but I mostly focus on identity. All right, so intros were quick. Just gonna talk a little bit about what OAuth is. We're gonna talk a little bit about OIDC, the differences between the two. There is a lot of confusion that I hear sometimes. Then we'll go over some of the vulnerabilities and common misconfigurations when you're developing your own custom web apps that need to interact with these authentication APIs. We'll wrap it up with a quick just token replay, attack demo, really just to show you the difference in the power of a bearer token versus other types of authentication in the cloud. Also, at any point during this talk, if you guys want to raise your hand or shout something out, please. I'm not a web developer. I'm not a developer of any sorts. I tinker a lot. I'm a guy that puts Band-Aids on grenades, right? And we hope for nuclear bombs. So I come in the clutch, I learn stuff real quick, and then we try to flip it and do something good with that. So I say all that simply because I'm learning too. I am by no means an expert in this. So let's have a good time and see where we get. All right, so what is OAuth in general? Not even just 2.0. What is OpenID Connect or OIDC? Why do they matter? Why am I even giving this talk today? So these two protocols are really, they're more than protocols. These two frameworks are really kind of the backbone of identity today when it comes to the cloud. A lot of people are using OAuth and OIDC and may not even know it, right? It's as simple as you've got Waze, and it's telling you where the traffic is. There's a cop around the corner or whatever, but you also want to listen to Spotify. So you're like, yeah, go ahead and give Waze permissions to talk to Spotify so I can listen to my next app, right? So these are kind of some of the things that we're talking about, right? Being able to authenticate or be authorized to use and access resources on behalf of just some random user across the internet, any internet. So essentially OAuth 2.0, it's a delegation protocol, right? And so it lets applications access resources on behalf of users. And it does that without having to handle passwords. And so the thing that's great about that means that the authorization server doesn't have to worry about passwords. The end user doesn't have to worry about passwords. Passwords aren't in your file systems. They're not in memory. They're not in your logs, et cetera, et cetera, et cetera, right? All the places we find passwords. So that kind of alleviates that piece to an extent. So there are still pieces that we have to worry about and we still have to secure, and we'll get into those a little bit. But these protocols are being used everywhere. They're used specifically for API calls, but we use them in mobile applications. We use them in SaaS all the time. And that's really what makes them a prime target, is that you can access them anywhere, anytime, all the time. And with cloud platforms like GCP, Azure, AWS, you have the ability to really quickly spin up these web applications that rely on these authentication and authorization frameworks, but they're not really doing any error checking or validation to make sure that your configuration is actually secure. It may work, but that doesn't mean that it works in a secure manner. Okay, so we're just going to start out with OAuth 2.0. So it was developed by IETF. It was finalized in 2012. So they actually have a whole RFC that's dedicated to them, 6749. That actually finalized in 2013 because they made an additional revision to it. But OAuth's been around for a long time. OAuth 1.0 was around for a very long time. By today's standards of like pen testing or red teaming or even cybersecurity, it was sloppy. It was effective, but it was sloppy. It's like throwing the noodle on the wall. My wife's Italian. Anyway, so if you're making spaghetti, you throw a noodle on the wall. If it sticks, like the pasta's ready, like that's what it was. Like maybe, maybe it worked. So there was a lot of holes in it, and so OAuth 2.0 came in order to try to bring more flexibility and to make the framework more extensible. OAuth 2.0 introduced 4 new grant types. It introduced authorization code, implicit authorization. Here are the fun ones: resource owner password credentials, and resource owners are you, the user, the person sitting on the keyboard, or client credentials. And the client credentials are the application that you built, the application that needs to interact with everything else in the wild. So you can still pass those credentials using the OAuth 2.0. Not needed, but you can. All right, so this is a pretty common looking page whenever you're interacting with OAuth 2.0. So this is IndieAuth, whatever IndieAuth is. That's cool, but it's going to allow. So when I log into my Twitter account, it would allow me to, or rather, it would allow IndieAuth to read tweets from my timeline and see who I follow. It even tells me what it can't do, and I will implicitly believe it, or I will read that long page that nobody reads, right? But that's really what OAuth looks like when you're the end user and you're interacting with it. It's really simple. You just say like, yes, I want it to be able to do A, B, and C. That's all it can do. And those permissions are just tied to that token. This concept is really important when it comes to OAuth 2.0 because a lot of people get one concept mixed up constantly between OAuth and OIDC. And it's that OAuth does not offer any kind of authentication. It does not know who the user is, does not know where the user came from, there's things that you can do to limit your audience and even limit where the issuer comes from, but there's no authentication that happens. It's simply a token that gets authorized to have access to some resource on behalf of the user. So if anybody has access to that token, they have the same access as that user does based on what it was given to that access token. Okay, so OAuth is relatively easy. There are a couple of terms that are weird and they seem not as intuitive as normal. Like when we talk about servers, there's a few different servers involved. When we talk about clients, when we're talking about cloud authentication, typically, not always, but typically when we talk about a client and server authentication communication, the client is actually the web application that is making that authentication or authorization request on behalf of you as the human or on behalf of some other entity that has actual access to some resource somewhere. In most scenarios, we refer to ourselves, right? We are the client. The machine we are is the client, but this is the cloud. We don't own those machines. The client can be a lot of different things. So the resource owner, that's actually who you are. As average Joe, you own whatever data that you have in the cloud, whatever frameworks, whatever services that you have access to, those are yours. And that's why you're the resource owner. So your web application, the whole point of it is to be able to mitigate that conversation securely and ensure that the web application only has access to the resources that the resource owner both has and has authorized. And those two things are not the same. just because you have authorization of something does not mean that because you create a bearer token based on your identity, that that bearer token has to have, you know, every privilege or permission that you have. You can actually make blank bearer tokens, which will give you back, you'll get a 200 OK, so you'll know that you're able to successfully authenticate, but you'll never be able to pull any resources back. So that's actually really useful for developers. All right, so this is a very, very, very basic authentication flow. This is more of an internal facing app or an application that's not going to be public facing at all. And we'll talk about a couple of reasons why. But just in general, that application on the left, that's your client application. Your user is the resource owner in the top right. And then your resource server in the bottom right. Those are kind of the big pieces here in this puzzle. So it's simply that you wanted to access something, so the application on your behalf goes ahead and prompts you as the user and says, all right, well, you can log in. You can use these different types of forms to log in order to grant this authorization, right? So let's say you use Google or you use Facebook or GitHub or any of these different providers. You go ahead and get that authorization grant. Once that authorization grant is received by your browser or your web app, you get a redirect URI. That redirect URI is going to send you to the authorization server. In a lot of cases, your authorization server and your resource servers are the same, especially if you're looking internally, but this authorization server is the IDP. So whether that IDP is Active Directory or Entra ID or you know, Okta, doesn't matter. Google, doesn't matter. It will always perform the exact same functions. You'll get an access token, and then you can use that access token for subsequent API calls. Now, in a more secure world, so that last one was very straightforward. Doesn't matter what you came from, if I'm on a Linux machine, a Windows machine, a cell phone, whatever, right? I always hit that same backend. That backend interacts with the API the exact same way. There have been a lot of exploits around that because not all operating systems, not all devices, not all software interacts with these APIs the same way. And so if you just have a backend, or if you don't have a front end that's sitting there that knows how to interact with the back end based on how that client web application would best work, you're going to end up with not the best results. You might still pull in the data that you're looking for, but it might not be formatted correctly. It might not come in you know, human readable forms and that type of thing, right? So this screen, this is backend for front end. If there's developers that are here, I'm sure that you've heard of this. But backend for front end basically just opens up the front end so that instead of having a dedicated just one service that has to handle every single API call for every single type of client in every single situation, which is going to get wrong a lot, you actually have a dedicated backend for front end. So based on the type of client or the type of user or other types of criteria, you will have a dedicated backend for front end that will then interact with those APIs specifically. So this is brought up because this actually brings in a lot of optimization around just client-side programming and scalability, because you don't have to worry about for every single time that you want to add in another API service or something else like that, that you have to add it into this massive monolithic front end that has to handle all these different things. You can just spin up another back end for front end, and it just handles that API. Kind of similar to how MCP servers are working nowadays. If you guys are kind of in the MCP world, you've got this other server that does like the translation for you, and that's what these frameworks are doing. So this is a detailed just authorization flow. This is when you're using a backend for front end. It is very similar to especially from the user standpoint, it feels the exact same. You don't notice anything different. What happens is instead of having that authorization request go all the way to the authorization server, then back to you, and then you get the token all the way from the authorization server, then you send it to the application. The application itself has a backend that acts for you on your behalf as a front end, and it handles that token request. So it kicks off normal. You have an authorization request, no user interactions required. You get the redirect URI, you get the callback requests, You send it, the backend for front end then takes over, goes ahead and does the token request, gets the token, sends you everything you need, sets up the session for you, and then you're good to go. So the backend for front end does a lot of the heavy lifting so that a lot of the authentication pieces, or really the authorization pieces at the endpoint, right, using the token and actually being able to use that token to make a call is happening on your backend for front end instead of happening inside of the user's browser. And we will talk about why that's also a problem here shortly. Okay. All right, well, there was a video there. We had a minute and a half video that was going to show authentication. Don't know why that's not working there. Interesting. All right, well, we might wrap up a little bit earlier. That's fine. So when it's used, OAuth 2.0 is mostly used when it comes to delegating access for APIs and applications, right? It's made so that some other entity, typically non-human, can make requests and interact with some resource on your behalf. It enables login, and I lightly quote, I'm air quoting login just because of what login means to some people doesn't mean the same thing to identity folks, right? But it does enable login with Google, Facebook, GitHub, all kinds of different frameworks without you having to create an additional account. Say that again? No. I'm still on OAuth. I'm still on OAuth. So the question was, he's asking if I've changed and hopped over to OIDC. No, but we're about to get there next. So this is used, and that's why I air quoted when I said login, because the login is different to some people than others. So if you actually look at the RFC and the documentation, it references logging in, it references authentication. It references a lot of words that are not correct based on the protocol itself. So that's that. But speaking of OIDC, the prophet has spoken, and we're here now. OIDC is an identity layer that's actually built directly on top of OAuth 2.0. So you cannot run OIDC without OAuth. You have OAuth, and then you have additional pieces to it. Now, OAuth 2.0 was originally designed for authorization, granting third-party applications limited access to user resources. OIDC actually extends its support to authentication, meaning that with OIDC, you can actually verify and assert the identity of a user. This is really important because, again, like I said, OAuth alone doesn't tell the client who the user is at all. It just implicitly trusts that bearer token, and then it's just going to go ahead and give access to the resources that the bearer token has access to. OIDC fixes that by introducing a new type of token that's known as an ID token. This is typically a JSON web token or a JOT token. This JOT token contains the claims of that user. So it's got the username, it's got the email, the user ID, and anything else that the user wants to assert about themselves or claim about themselves. OIDC is actually a dominant standard right now, which is kind of interesting because when you look kind of statistically as to the progression of OAuth 2.0 versus like OIDC, OAuth 2.0, there were people that really were against it. They did not feel like it was secure enough. With this secondary layer of OIDC, I mean, it is hands down one of the most dominant, if not the most dominant, cloud authentication protocol that exists currently. So this is what it looks like, again, from the user standpoint. So Core Stack is just a learning platform that I use, right? In order to log in, you can create a new account, or you can log in with a local account with Core Stack, or you can sign in with Google, or you can sign in with GitHub. So the ability to be able to not even create a new account with a completely different system that you've never touched, and just click that, log in with Google, and then you get redirected, and now you have an account. You just use your Google account. This is OIDC, and we see this all the time. I can't remember the last time that I've actually logged into a web app on my phone, because most of the time it's just like, you want to just use that account? I'm like, yeah, Google it up, dog. Google it up, make it easy. Who wants to remember another password? All right, so how it works. Again, like I said, it does extend on the 2.0 authorization, the OAuth 2.0 authorization code flow. What it does do, it adds an additional token, and that token is going to be a JOT token. And the user identity is encoded in the ID token. Now, this is an interesting thing. So by the RFC standard, the user identity is encoded. However, JOT itself is not a standalone framework. It's an extension of 2 other frameworks. There's some really cool JSON stuff that's out there. Most of this is JSON web signing that we're talking about, and that typically uses encoding. But there's also JSON web encryption, and with JSON web encryption, the entire thing is encrypted. Like it's not just encoded. That's very, very hardcore stuff to break into. It's just not common. You just don't see it very often. Most of the time when we're talking about JOTs, we're just talking about JSON web signing with these additional security features. So it typically starts with just a user request. That user gets authenticated by some IDP, whether that's Google, Active Directory, Entra ID, anything else like that. That IDP will give the authentication code. This can come in a lot of different ways. It can come inside of the actual URI itself. It can come inside of a body. It can come inside of other forms of metadata, just depending on the IDP. A lot of times it just comes across inside of the actual return URL. So once you have that, you can use that return URL to get redirected back to typically the same IDP, but not always, but typically back to the same IDP. You've got your authorization code. That authorization code allows you to get a token. Now you have your bearer token, and you can use that token. Now, the difference is, in this scenario, instead of just getting the bearer token, you also get an ID token, and that's where that JWT or that JOT token comes into play. Again, so this is just that flow for OIDC, right? You've got the user request gets authenticated by IDP, which did not exist at all in any other flows that we've talked about before. So it actually knows who the user is before the user gets authorized to anything. You get the authorization code that gets sent back to the browser, and then the browser goes ahead and gets the token, and then can use that token for subsequent API calls. So not to spend too much time on JOT, because there's like a whole bunch on JOT. Like, if you guys like to break stuff, if there's red teamers out there, do it. Do your research. Do your research. It's awesome. That's just me. I love cryptography. But JOT token is basically made up of 3 parts, right? You've got a header, a payload, and a signature by RFC standard. You can implement JOT tokens and IDPs in a lot of different ways, and they don't necessarily have to follow these standards, but this is what the standard is via the RFC. What's interesting about it is, like I said, sometimes the body's encrypted, sometimes the body's encoded. All this typically is going to be pointed out inside the header. The header is going to say, hey, this is going to be the encryption algorithm that we're using. This is going to be the length. This is what it's going to look like. The issue with JOT tokens and why they're such a prime target, and the reason why literally I'm having this talk today, is because JOT tokens are actually incredibly secure. They're awesome. They're amazing. The code that we write to verify JOT tokens, not so good, not so amazing, not so strong. And the problem is, unless, again, you have to know what you don't know, you have to have some really strong error validation to understand that, like, okay, well, this token went ahead and passed, and I got back the resource that I needed, but did the verification actually go through? Did it actually look at the ID token, or did it just look at the bearer token and it got the resources? When it looked at the ID token, did it look at the entire ID token, or was that ID token expired last week and we don't validate for expiration dates? So JOT tokens are prime targets, left and right all day. If there's any bug bounty hunters out there, you know what I'm talking about. All right, so when is it used? Always, all the time, everywhere, online. If you log into pretty much most modern platforms nowadays, modern applications tend to give you some sort of SSO type feel via OIDC, right? That's one of the main reasons why when you open up your phone, regardless of what type of phone that you have, you don't have to like log into your apps every single time that you log into your apps and things like that, right? We don't have to cache these passwords anymore. We have tokens to do these things for us. It enables secure, more secure, I'm not going to say the most secure, but it enables more secure login across systems, especially across other things, other types of authentication and authorization, such as like basic or anonymous, or but those things do exist. They exist out there, and the pen testers and bug testers will let you know that it's really interesting when you start messing with claims inside of a JOT token, and you throw in guest, you throw in anonymous, you leave it blank, you throw in an actual null variable. It's kind of interesting to see what happens. So OIDC is widely used for federated identity and single sign-on. So again, when you use like Azure AD or Okta, something like that, you're pretty much guaranteed to be using OIDC underneath the hood. What makes it better, again, is it is just OAuth 2.0. It's just with this, you also have authentication. OAuth does not care at all about who is the person that's making this call. You can add in some flags, you can add in some parameters to narrow that down a bit, but there's no authentication saying that this came from a true proof of source, a source of truth rather. It's just out there. Whereas with OIDC, before you even progress to that stage of authorization, you've already been authenticated with that IDP. So we're going to swing back to OAuth 2.0 for a second, and we're going to talk about some of the vulnerabilities with OAuth 2.0. There are a few vulnerabilities that are targeted around OIDC specifically, but most of the attacks that really you see in the wild that work, that are successful, whether it's a bug bounty or it's something like 0 day or anything else like that, it's not OID specific. It's usually the OAuth underlying process of getting that bearer token. Because again, if you can get that bearer token and there's no other verification in the system, you're good. Or if the system doesn't know or it believes that you verified in some other way. And we'll talk about that here in a little bit. So one of the most common OAuth issues is a missing state parameter. And this parameter is kind of important because it links the authorization request to the actual response from the authorization server. So that's what actually prevents CSRF. Without that, anybody else can just hop in if they're able to listen in on your network, or for whatever reason they're able to grab this conversation, they can just hijack your session. There's nothing to stop them from hijacking that session at all. By having that state parameter in place, it highly mitigates, does not completely prevent, but it highly mitigates that from happening. The second issue, and this is the one that I see the most common when it comes to bug bounties, and in the past when I've done security assessments across Entra ID and just some of these create your own application processes that some corporations have in place, is an overly permissive redirect URI, and then an overly permissive redirect URI validation. So the URI works, the redirect works, you go to the authorization server, it tells you, all right, awesome. So I've given you the callback, come back over to the server. And again, 90% of the time, if you're out in the wild, if it's not something custom you built, it's the same server. You went to Google, Google gave you the callback, you hit some other endpoint, back on Google, 99% of the time. But the issue is an attacker can actually put in their own redirect URI, right? If they're able to hijack the session, they can just say, hey, I'm gonna point it to my own server. My own server's got a nice IDP server that's running within the standards of RFC, so that authentication process is gonna go. It's gonna get a proper token, right? And if that user does actually have access and does have authorization to specific resources, more than likely you'll get access to some things. Depending on what type of environment that you have, in federated environments, like if we're talking about ADFS, that token a lot of times is not just tied to one service. It ties to like a slew of services. Like there's a whole bunch of different things you can do and move your way laterally. And then now you're laterally and you're in a different, you've got a different access token that you have. And from there, you can just continue to escalate and escalate and escalate, at least in the Windows world. Linux world, not so much, but in the world of Windows and ADFS, yeah, once you get in, you're good. Okay, so I'm not going to spend too much time on this slide, but this is the same thing that we looked at earlier, right? It's still got the BFF in the middle. The only difference is now the first step, instead of it being the user saying that, hey, I want to access some application that's out there, they've already been hacked, they've already been pwned. Some attacker has been able to inject some malicious JavaScript or whatever to run in their browser, as an example. It could be a fat application, it could be any application. They will all support this flow, but this is a good example, right? JavaScript. So JavaScript goes ahead and it starts off this authorization flow on your behalf as the user, right? Goes out, everything starts as normal, everything works the exact same. The difference is in this script, instead of this just being just a plain HTML request that just goes out normal, it's going to be called inside of an iframe. And you can make iframes incredibly tiny. You can make iframes invisible. You can make iframes in the background. So this entire call, this person's just like on Facebook or doing whatever, checking their mail, and they have no idea that all this code is just running in the background, right? So when that happens, you go ahead and you get the redirect URI. The attacker actually jumps in there and it'll stop that callback. And this is where the attacker sends that redirect back to their own server. So you see that right at step 7. And after step 7, the user is no longer in this authentication flow at all. At this point, this is an actual authenticated and authorized flow from that attacker. If you looked in your logs, everything looks good. If you look everywhere else, everything looks good. For everybody except for whoever that user was. He's having a bad day, probably. Of course, so that video doesn't work either. All right, cool. Don't worry, there's only 2 videos, so that was video 2. Let's, cool. All right, so additional OIDC vulnerabilities. One of the biggest ones is discovery document tampering. This is the way that you find, it's one of the ways that you can find some of these redirect URLs and some of these URIs. Many implementations of web applications actually trust discovery of documents and the issuer blindly. There's no verification of that. So like when you get a document and it says that it came from X, it came from Google, it came from BSides Las Vegas, there's nowhere really inside the application that's verifying that. So an attacker can actually just create fake tokens. Excuse me. So as long as they're following the RFC standards, that application is going to go ahead and go through its normal flow. Now, one of the reasons why this is possible is because a lot of times when web developers are creating applications, they're either in a rush, they don't know, or they haven't fully switched from dev to prod, with that application, is they're not checking some of the parameters inside of the tokens itself. So the token has parameters such as the audience. Who is this token actually for, right? This token is for, DC05. But I'm presenting it over to file server 12, right? Why is it here? It should not be here. The issuer, right? The issuer should have come from, this is bad web implementation.net, and it didn't. It came from, this is really, really bad web implementation.org, right? So we're not looking for that. And there's also another state parameter known as a nonce. It's that one-time use. And a lot of times that's not even in place. And if it's in place, it's not being verified. Unless you're using a really kind of like major framework, I've never seen that just automatically added in. So if you're creating custom applications and stuff, the parameter for the nonce is not just going to be there on its own. And even if you create the nonce, the verification for that nonce is not going to be there on its own. So it'll pass, and you'll think everything's good, but it's not actually verifying. And again, this is one of the biggest issues with OIDC is lack of verification, and there's no notification to you as the developer that yes, you succeeded to authenticate or to authorize, but you didn't succeed with your verification of the data to get to that authentication or authorization. Well, this one is not a video. This one's live, so hopefully demo gods are better than my YouTube gods, right? And I've just got, I've got an IDP and I've got a vulnerable web app that's there. Essentially, I'm just going to log in. I'm going to grab that bearer token. We'll curl it up, and we're going to pull in some protected resources that I should not be able to get. But this bearer token, like I said, does come back across in the URI. And let me just do this. We got a Docker container. Cool. Awesome. All right, so got the world's fanciest web application here. All right, look at that CSS, guys. Look at that CSS. Call me. All right, let's go ahead and log in. Install this template as well. And we'll just call it me. Doesn't matter. 1, 2, 3, 4. Then we'll go ahead and authorize. Cool. So I'm trying to pull in. There's a protected route called, it's slash protected. You can't get it to it unless you've been authenticated with the system. So I'm gonna go ahead and just grab this handy dandy information here. So this is the actual bearer token that's here. The bearer token does get returned back inside of the URI itself. So I just went ahead and made it easier for myself for when I'm doing presentations to just like, yeah, why don't you just present it to me so I can just copy and paste. So let's copy and paste. Hop over here, hop into Narnia. Yeah, I'm one of those guys. And yeah, and just like that, completely different computer, completely different operating system, just use the same bearer token. I was able to get granted access to it. So this is just to show you that it's not about the security necessarily or the encryption or even the encoding when it comes to creating these JOT tokens or creating these like intense frameworks. Really, a lot of times where the flaws come into play, they come into play around the verification. So like you can have a token with the most security information in the world. If your application is not checking for that and then not responding appropriately based on what it finds, you're going to find yourself in a situation every time. All right, so the reason this worked is there was no token binding, which means that I'm not using any layer of the session in order to tie into the actual token that I'm using as well. That's essentially a secondary signature. So if you change anything about the token or anything about the session, you know that something has been changed and it'll go ahead and die off. The second thing is my token does not have expiration dates, right? It's long-lived token. That's a very common thing that we see out there. So even if a token's been exploited a long time ago, it's the same thing like you see with service accounts. They need to have meaningful expiration dates, and the best thing that you can do, especially in a world of tokens, is that you want to have short-term lived tokens and just request and verify them on a more regular basis. You don't want to just have a long-living token and just hope it's still doing everything that you want it to do. The next thing is the no audience or the issuer validation on the resource server, right? So nothing to validate where it's supposed to be coming from, and nothing to validate who this token's actually supposed to be served to. No token introspection or revocation support. This is kind of added on to more of like once you have a framework in place and you have the ability to verify, what do you do about it, right? Do you reject the token? Do you kick the token back? Do you alert the fire squad and they come down with the pitchforks or whatever? That's what you do there. And then like no logging or anomaly detection. So anomaly detection is a big one, especially in the cloud-based stuff. If you're building your own applications, it's a little bit harder. If you're using Azure, or if you're using AWS, it's already built in for a licensing fee. But it is there though. So the impact of this type of attack, I mean, it is a full account impersonation. Again, there is no verification, and there's not going to be any type of secondary, tertiary, or any following type of validation of that token. As long as that token is valid and that it hasn't expired, it's going to stay valid. One of the cool things for red teamers and the things for blue teamers is the fact that whenever you issue these tokens, typically in almost all cases, they bypass all MFA and login defenses around MFA and that type of thing, right? Because they are meant to be used with non-human entities. So worse, again, when we're talking about federated environments, one token might give access to dozens of services. An attacker can pivot laterally, gather data, and even abuse APIs, escalate privileges, or destroy records. I don't know why I went up at the end of that like that was positive. It wasn't positive, but I felt like I was bringing it home. So detection and mitigation. Again, most of the things that I've talked about have not been any actual attacks. Nothing I've talked about has been red team centric. So I work in the world of identity. Most of the stuff that I deal with is identity. And besides like brute forcing and the stuff we've been doing for a very, very long time, most attacks on identity don't really come from any kind of like twisting or new Breaking Bad cool yellow jumpsuit type thing. They really just come from misconfigurations in the implementation of these frameworks. And then you have some guy who's sitting around or girl that takes the time to find that hole, find that spot that you didn't cover, and they're off to the races. So preventative controls are use short-lived tokens. Make sure that you validate the audience. Use a nonce. The nonce will stop almost all token replay attacks because it changes every single time. If you use a nonce, make sure that you verify that you use the nonce. And one last thing that I'm just going to give like a tidbit, because I might have known somebody who did this, and that's why they created this talk, was in Node.js, there are two methods when it comes to verifying an OIDC token, that JOT token. There is a verify method, and there is a decode method. If you don't read all the way down to the bottom of the page, you only got to the decode message and not to that verify message, and they do similar, but not the same things. The decode method will actually say like, hey, yeah, this is a valid token. You can use that token. It's good. But it doesn't verify it. It doesn't say that the information that I got from it that is in the right format is actually the information that should be in that token. So it's little things like that, really on the developer side of trying to figure out and make sure you learn the things that you don't know. So for me, when I had to create an app in the beginning of the year, I did not know a lot about a lot that I did not know, and I went down a lot of rabbit holes and broke a lot of things and pissed off a lot of people, but we got there. There are a lot of detection measures. There's a lot of ITDR solutions around this. There's a lot of monitoring, especially with AI nowadays. Everybody and their mother, any of the big cloud platforms are going to offer some kind of heuristic behavioral analysis implementation. Again, it typically costs money, but for most organizations, that's not something you can implement on your own. You do typically have to outsource that to a third party. So OAuth, OIDC, powerful but complex, very small configs, missing one word, missing one parameter, not verifying one thing. It can negate every single thing else. So little mistakes can cause large issues. And really, you just have to continuously test and monitor your environment to ensure that your applications are doing exactly what they're supposed to be doing, and only the identities that you want have access to the data that they're supposed to have access to. And that's it. I think I made it with a minute and a half to spare.
So your certificates, would you say maybe like a typical workday plus like a couple hours for your hardcore devs?
You're saying as far as securing, how much time they're putting?
When does your cert expire?
Oh, so that depends. It depends on the resource, right? It depends on the access, because you created that authorization for a reason.
And like what I'm thinking of is, like your login cert, but there might be other kinds of things.
Right. So because you have to have some kind of human interaction, you have to have some kind of human interaction in order to renew that token. It's how often does that human need to interact, right? So if you have something that runs every single night, maybe the human, if it's just updating something, right, like it's WSUS or something like that, maybe you just need to interact with that once a week. If it is financial software, right, and it's updating, transactions for the entire day, yeah, you might want to look at that every single morning and make sure that you have a refresh token and that you're good to go, so. But that is operational, not technological.
In the beginning of the talk, you drew an interesting parallel between this and the MCP servers. I was just wondering if you've seen any similar attack vectors in the MCP space, or if anything is like parallel to that work.
Oh, as far as attacks?
Yeah.
And the MCP, no, not yet. But they're coming because there's so many MCP servers that are openly available, like on GitHub, and script kiddies don't verify their text, and you're trusting some third party to make every single API call on your behalf. So yeah, you should probably read through that code before you hit go and do this thing using my credentials.
So can we expect like similar kind of identity problems with that space as well, probably?
As far as MCPs specifically? Yeah. Well, I think that's really where it's at, because an MCP server is just a translator, right? That's all it is. It's taking out the time for you to modify your code every single time that an API endpoint changes or that you want to interact with something else, and it can just do that for you. You creating an MCP server, I don't really see any inherent issues with that. Depends on, of course, like how you're interacting with it, but I don't see any inherent issues with that directly. It's more of when you trust that code from somewhere else, because you're going to give it your authentication, you're going to give it authorization, it's going to interact with APIs that you think it's interacting with, but if you haven't done any kind of SaaS testing at minimum against that code, I wouldn't run it.
Okay. Thank you.
I'm gonna ask something that's more specific. So, I mean, if you can't answer this question, that's okay, because it's very specific. So the CSRF attack, the flow that you demonstrate earlier, so that one, so is that the condition for that to work is because that flow uses the set cookies? So if, for example, if I don't persist the token on the disk,
Yeah.
would that prevent this kind of issue of happening?
So I don't know the full answer to that. I don't want to say the answer is yes, but I will say this, that regardless of if the cookie is present or not present, it can still work. It does depend on the type of cookie that you're using, because you can execute this code regardless of if the session is stateful or stateless.
Yeah, that's interesting.
Are you familiar with the passkeys at all?
No.
Because some of the issues you've talked about, like lack of revocation, lack of logging,
yes,
lack of transparency, I believe affects passkeys as well. It's hard to, when they go bad, you don't know they go bad. If they're stolen, you don't know if they're stolen. And they are a pretty cool thing, but there's just little flaws in the implementation that sound like this.
Yep, yeah, and it's because you're using some other method in order to represent your credential set. You know, we see the same thing with Windows Hello is pretty solid, but a few years back and stuff, you know, when you're using cat cards and things like that, like it's interesting, right? Because it's just tying your password or your identity, not really your password, but your identity to like some PIN that's on your system. So if your system gets compromised, all you have to do is set a new PIN. You don't have to change your password. You don't have to worry about that.
In your example earlier, you had the token coming back from your IDP in the URI. And then in your list of misconfigurations, I saw both URI containing the token and Pixie. Isn't Pixie supposed to solve that, or am I completely off the reservation there?
Yeah. Okay, hold on. Let me go back a couple slides. It's a good question. It's a good question. I don't want to say it wrong, and I got notes for this. I was waiting for this question. So Pixie, proof key for code exchange. We're talking about, right? Yeah. So it is an extension of OAuth. In this particular case, the access token is accessible in the browser because it was stored like in memory or in DevTools, and that's what it's supposed to simulate. It's supposed to simulate non-secure storage. Right, because like I found them, well, not me personally, but they've been found even in logs, right? Like these credentials, right? And that's what that's supposed to show.
Okay, so if my IDP really wants to give me the token in the URI, that's not fundamentally flawed. I just need to be very careful with how I handle that.
Exactly, and that's really the takeaway for this entire talk, right? Is like the framework itself actually works really, really well. You just have to be careful in the way that you implement it, because there's a lot of pieces to it, and like, you miss one thing, you might get a valid token, but it's not being verified, right? So it's valid for some, but not for the rest, right?
Thank you, Daryl.
All right.
Thank you guys for coming today. Hope to see you guys tomorrow. Have a great rest of your evening.
Thanks a lot, man.